Okay, so in this stream, hold on, I gotta make sure that it's not like doing stupid stuff. Okay, wait, I can actually scale down the bitrate a lot. Okay, that's already down to 12. What's YouTube at? 12. Okay, we're just gonna do 1200 bitrate. We could probably even go lower. So we're going to discuss the Ryzen and chipsets. So we'll go over like a few things here. We gotta find a block diagram. Oh, here's a good one. Okay, we'll just use this. And those of you who are watching, feel free to discuss your experience if you already know how to overclock. But anyway, this is going to be like a discussion on, and if nobody really cares, I'll just switch to playing a game later. But I thought we'd go over this. So last time I did 2 streams. The previous stream we were overclocking with a Crosshair 6 Hero, and the one before that we were doing the MSI X Power. So believe it or not, those of you who were here last Saturday, yeah, Friday I think was MSI and Saturday was Asus. But yeah, so Asus was having some issues, or like at least when I was overclocking it, we saw some really weird wiki wonky, as Jensen Wong would put it, wiki wonky things that were happening that were not supposed to happen actually. So what we'll discuss this time around is how some of the technical terms that we should keep in mind when we're talking about Ryzen. So there's a really good technical article. It's in a forum actually, I believe, on AnandTech, and it's done by the Stilt. He's a golden member on the forums there. He's also on overclock.net, and he's very knowledgeable when it comes to overclocking. So highly recommend reading his post. He has the full post there. It's very in-depth. It goes over a lot of stuff that nobody actually knew anything about prior to Ryzen's launching, and then when Ryzen launched. So overclocking Ryzen is actually quite a bit different than overclocking traditional CPUs or previous AMD CPUs or even Intel CPUs. It's a lot more, I think, in the next coming weeks and months, the way things are going to pan out with microcode updates from AMD, overclocking Ryzen is probably going to become more like overclocking a graphics card, because when you look at how the P states and the different things work, some of it's there, but it's very not really. It doesn't give you a lot of options to keep the power saving features and all the different voltage regulation that Ryzen has in it, like things that control XFR, for instance, things that control just the normal boost for something like the 1700, like the non-X. So when you overclock Ryzen, you lose out on a lot of those power saving features. And if you're someone like me who overclocked in the past, like with Intel and even with AMD, like AMD FX, AMD Phenoms back in the day, like the star topologies from like 2009, 2010, you know that it was basically straightforward. If you have an unlocked multiplier, all you do is you increase the multiplier until you're unstable. Then as soon as it crashes, you slowly start increasing the voltage to find out where your stable point is at that higher frequency. So with Ryzen though, it appears at first that it has that functionality for overclocking, but if you do that, if that's your approach to overclocking Ryzen, then you lose out on a lot of the power saving features. Now, interesting enough, with MSI's X Power, let me put a picture of that, I guess. MSI X Power X370. Let me find an image of this. It's a really nice looking motherboard. And just throw it on here so people can see. So with the MSI X Power, the funny thing about this motherboard is that, what the, why did it do that? Okay, so with this motherboard, it's actually running a Giza, and that's AMD's something. I forgot what the actual terminology is, but it's basically AMD's microcode for their CPUs. It's required for the BIOS and the UEFI. This is on 1.001, and this is the version that was out back in January. So this motherboard is actually using a much, currently, at the time of you watching this video, and that's why I'm doing this as a live stream, because it's going to be outdated in like a month, or maybe a month or two, or whenever MSI decides to actually get on board with updating it. But anyway, a Giza, I call it a Giza, whatever. It's the microcode from AMD. At 1.001, at this revision, which is from like the beginning of Q1, so it's really old by technology standards, software and microcode firmware standards, there's a lot of bugs. And one of the interesting things is with this version of the microcode, when you leave the voltage on auto and you tune the load line calibration on this particular motherboard, you actually get the ability to maintain your downclocking and your low power states. So let's say, for instance, on what I found when I was overclocking with this motherboard is I would set 3.9. So I would do like 3.9 gigahertz to see if I could run at that. And all I had to do to get that stable was I had to set load line calibration to mode 4, which is, like, if we draw it out here, I'll try to see if I can draw like the load line. But basically, with a given V core, so if this is whatever, I don't know why this is so big, but anyway, voltage, and this is what are we doing? I don't know. Anyway, you know what I'm gonna draw. Basically, I'm gonna draw for a given voltage. You get V droop. So you have these different modes where for a given voltage at full load the voltage will drop. So what happens is, and why is Paint being dumb? You can adjust it with these different modes. And the MSI motherboard actually has a lot of modes. It has like a total of 8. So you'd have, oh man, why? You have like mode, we'll say, okay, with some motherboards it's called level, and this font's still way too big. So you have mode 1, which is extreme, sometimes referred to extreme, and you never want to use that. Then you have mode 2, mode 3, and so on. Mode 4, mode 5, mode 6, and whatever. So anyway, it goes on. So the lower the number, apparently, the more V droop you get. So that means the less compensation the voltage regulator will do. Like, it means the lower, it won't apply as much voltage. So normally, like, no overvolt would be down here. So this would be no OV, no overvolt down here. So that's kind of like an auto is somewhere around no overvolt to mode 6 or yeah, depending on the motherboard. Typically it's not, like, it won't be a whole lot. So what I found was I could set this guy, I could set 1800X at 3.9 gigahertz LL auto V core with mode 4 LLC. So I could get my computer with my MSI motherboard, I could run this thing all the time with 3.9 on all 8 cores, and I could maintain with this microcode and this BIOS on this motherboard, I could maintain a down clock of 2.2 gigahertz, which is the default, and I could ramp up all the way up to 3.9 on all 8 cores, doing Cinebench, Blender, all my testing, Ada64, Intel burn test, you name it. And it was pretty good. Like, the maximum voltage it would use under full load was like 1.345, somewhere around there, maybe 1.36. I don't know. I don't really remember. But anyway, it wasn't until I tried to go to 4.0 that I ran into a problem where I see the V droop. I need more voltage at full load. So at that point, what I did was I set it to mode 1. Now with mode 1, again, at 4 gigahertz, mode 1, it's stable. But at that point, the voltage at mode 1 was pushing it all the way to like 1.39 or just around 1.4 for 4 gigahertz. So that means that my CPU is actually pretty good. It's probably within the top 60-65%, somewhere there to the 70% range in terms of the overclocking CPUs. So not that great, not in the top 20%, but it's definitely in the top 60, or I guess top 40%. So yeah, so that's with Agisa 1001. So apparently that means that you could keep your low power if all you were doing was using auto vCore, meaning you don't touch the voltage, you don't key in a voltage, you just change the load line calibration, and it would actually work. Now that's actually pretty surprising because, so I was thinking with the newer ones, it would be better. Like, it would just be better. Because what would happen is, as soon as I keyed in a voltage and like 4 gigahertz, I noticed that it was always pegged at 4 gigahertz. Like, it wouldn't downclock anymore, and the voltage wouldn't downclock anymore. So the voltage, that's normal. But I had all the power saving features turned on, and I noticed it wasn't downclocking anymore. So, and that's because the P states on Ryzen get disabled when it detects that you're running in overclock mode. And the key things that activate overclock mode are: 1, manually tuning the voltage, manually setting the multiplier, or both. And what that does is that will disable XFR, that'll disable the turbo, and all the voltage regulation features that it has, which is actually kind of a bad thing, because if you remember overclocking the AMD FX line, or even the Intel stuff, you can keep all the power saving features on, and it will actually still boost all the way up to your maximum frequency. So I have a YouTube account. Yes, I do. Malik Monk 5. What's going on? You're talking about my. What are you talking about? You're talking about? Were you watching me from the overclocking videos, or are you talking about like the Tales of Berseria and the live streams from last week? I always mean to put the timestamp. I don't even know why it always doesn't show. It's there. YouTube chat should be on. I think it's on. Oh yeah, it is on. Wow. Malik. What's BCHS News? Huh? Okay. Okay, that's cool. A little off topic for what we're talking about here, but were you watching the overclock live stream? I don't remember. I remember. I recognize your name. I guess you were watching my Tales of Berseria or my Nier Automata streams. But we're doing kind of like educational one now. I may play some games later. But there were some people who wanted to come in here. I'm just giving them a couple minutes. I'm just discussing my findings so far with this. Hmm? I'm confused right now what you're talking about. Subscribe, what? Well, let me finish the discussion here first on the Agisa 1.001, because this is actually very interesting in the sense that with the later revisions of Agisa, like for instance, well, okay, we'll talk about that one here, but like with the later editions, let me just make this longer. Wow, Paint is actually pretty terrible for doing this. But anyway, you get the idea. With 1002 and 1003, which I believe 1003 is the current one. I'm not 100% sure anymore. But I know that with 1002 and 3, that's the one. One of those ones, Gigabyte and Asus are on. And I think ASRock is also. I'm pretty sure ASRock is also on those revisions. So those are the ones that have the better, like the memory clock adjustments where you can get up to like 3200 megahertz. With the MSI one, the memory, you can actually choose 3200, but getting it to run 3200 is very, very dependent on having you just getting lucky with the IMC that your chip has. Mine is an average overclocker, but it doesn't have a very good IMC. So currently with the G.Skill Flare X memory, the highest speed that I've been able to get my RAM running at is 2933, and that's with 3200 megahertz RAM sticks. So, I mean, take that for what it's worth, but you definitely want high frequency RAM with Ryzen if you want to get the best performance out of your platform, or this platform. So, with that, we'll move on now to the discussion on Agisa 1.002. Now, let me just resize this thing like 200%. Oh, that's not what I wanted to do. Let's, how do we just... Man, I just want to increase the canvas size, but if we have to delete this stuff, we'll delete it. Whatever. Anyway, hey Transformers. Okay, yeah, so I was gonna wait for some people like you to join before I talked about the whole motherboard situation. So what I was talking about earlier was how overclocking Ryzen. So I did a bunch of research on this over the weekend, and I think that in the long run, or actually over the next couple of months, overclocking Ryzen is actually going to change a lot. In the sense that, based off of my own testing, my own experience overclocking it and watching other people overclock it, and reading their findings, watching different videos and stuff. So, it's... Right now, overclocking Ryzen is kind of, in my opinion, not really worth it until we get microcode updates and the platform matures a little bit more. And that's what I'm going to talk about here. So I'm just going to do a quick refresher since you weren't here in the beginning. There was only like my viewers on Twitch were talking to me, but then we kind of got off topic. So with the MSI motherboard, it's interesting in the sense that it's still on the older AMD firmware or the microcode from January. And the nice thing about, okay, there's good and there's bad. The good thing about it is that with Auto VCore, you can still maintain your power saving features just like you would expect if you were overclocking an older AMD CPU or an Intel CPU. Yeah, we'll talk about RAM. I was sort of segueing into RAM, but we'll talk about RAM again. Because RAM is actually really important right now. And in fact, I really think that if you want to overclock anything on Ryzen right now, it's best to overclock the RAM and just leave the CPU clock at stock. So with the MSI motherboard, anyway, you can if you leave the voltage on auto, you up your multiplier. So like what I've written here, you can see it says my 1800X, and I remember we did this on my stream back on Friday with the MSI motherboard, 3.9, leaving auto VCore, and then all I did was I tuned LLC to mode 4. So you see I've sort of drawn what mode 4 looks like in terms of the V-droop percentage. Yeah, so like this for instance, like 3.9 with auto voltage, with mode 4 LLC, the voltage range, voltage range is anywhere from 1.2 all the way up to 1.39. I'll go ahead and say 1.4. So this is actually, no, it doesn't actually go that high on mode 4. So with mode 4, your V droop is going to be 1.36, and your peak, because if you're overclocking with load line calibration, it's the peak that actually matters, or that's the thing that you need to worry about. So let's keep in mind. So the peak would be, I remember it was around 1.44, or no, actually, yeah, it's probably around 1.44, maybe 1.45. We'll say 1.45 to be conservative. That's the peak. So what that means is, if we go down here a little bit, you have, you know, when you load up the CPU. So this line here represents load. That's supposed to be a straight line. And then the load goes away. So you fire up like Cinebench, like you saw me doing. What happens with the voltage, and we'll just put that in like orange or something. The voltage curve, it actually, so here it's at an idle, or it's like, let's say it's like, here's your idle voltage. So as soon as the load goes, then it starts going down. And then it kind of like stays. And then right after the benchmark ends, it like shoots up. And then your VRM, if it's a good VRM, will cut it back down, and then it'll go back to idle. So, no, yeah, I know how it works. I'm explaining it right here. Maybe there's a delay in the chat. But anyway, the orange line represents the voltage, and the black line here represents the load on the CPU. So if you think of this here, we'll say this line is 100%. Hold on. Whoops. I want to do this in black. 100% load. And then you can see the V droop. So, okay. Yeah, so the peak is what I'm talking about. And the peak, we'll call this up here 1.45 volt. And my idle, or my voltage with the normal load line would be like this or something, or maybe something like that. This is the V core. So this is the auto stock V core under normal light load. If we're talking about like idle, it'll probably be like, yeah, around 1.2 something. So anyway, that's why I put the range 1.2. So that means that if you overclock on the MSI motherboard, currently, because it's so behind with the microcode, you actually can get the best results. I know that sounds really weird, but that's from my own testing, because with this, I maintain my low voltage. If you're, I don't know, were you watching? You watched me overclock the MSI board, right? And when I overclocked it, the downclock voltage was, or the idle voltage would go all the way down to like 0.5 or 0.7 or somewhere. It was like really low, and then it would spike up under load to 1.36, I remember, and then yeah, so yeah, that's how load line calibration works. So for 4 gigahertz, what I had to do is I had to use mode 1, which is extreme, and mode 1 is bad because with mode 1 you get, now what'll happen is during load it will actually like overvolt, and then after the benchmark ends it will spike really high, and then it has to come all the way down. So that's why you don't use mode 1. Yeah, that's right. That was the idle voltage. So yeah, it would spike really high. So I could do 4 gigahertz with mode 1. So I could do 4 gigahertz auto V-core mode 1 LLC. So I could do that, and I was stable at 4 gigahertz just doing LLC mode 1, not touching anything else. But that's not good in the long run, because you're not supposed to use mode 1 for 24/7. I mean, you can, but you don't know what could happen, right? Like in the long run, because of all these little micro peaks that will keep hitting the CPU and going through the VRM. You're really like stressing out your VRM a lot and your CPU over time. So that's why we don't use mode 1. So mode 4 is okay, mode 3 is okay, mode 2 is okay. I was almost stable at 4 gigahertz with mode 2, but it still would crash randomly. Like I would get random errors, applications would crash. I actually tried running it at mode 2 for like a day, and I tested like video games on it, playing MMOs like Final Fantasy 14 and stuff, and it would work. But like, I'll give you an example of how it's not stable. It's like you could be playing the game. If all you're doing is you're playing the game, it's probably okay. If you start like playing the game and then on the second monitor you fire up like a YouTube video or something, one of those two might crash. Like the browser might crash or the game might crash at some point. So that's when I knew that I needed to up the vCore. Unfortunately, as soon as you up the vCore with this microcode, the older microcode, it does exactly what the newer stuff does. It disables all of AMD's power saving features that they put in for Ryzen, like all the different P states, get the ones that like downclock it, they get all disabled. And yeah, so with a Gisa 1.1, manual vCore disables XFR, turbo, and lower P states. So that's what happens as soon as you key in a manual vCore for a Gisa 1001. So that's what I found out with the MSI motherboard. So the MSI motherboard, if all you want to do, if you got a golden, basically what I'm saying, the summary of this, so the TLDR for this, talking about MSI specifically, currently, is if you got a golden chip, the MSI motherboard is the best one for overclocking. Because if you have a Ryzen 1800X that could do 4.1 at, say, 1.3 to 4 volts, which is like, you're probably like within the top 5% at this point, then this is the motherboard for you, because you can just set it and just forget it. Like you can overclock to 4.1, set LLC to like mode 3 or 2 or whatever, mode 3 probably, or 4, and you're set, because that's going to be fine for like forever, right? So you don't even have to update the BIOS unless you really want to run your memory at 3200 plus. But for me, with that BIOS, I was running 3.9. So MSI BIOS version, we'll just say 1.1. BIOS version 1.1, I could do 3.9 gigahertz at auto vCore with mode 4 LLC, 2933 megahertz RAM, 34 1T. So I could do this with the MSI, with the stock BIOS from February 22nd. This is the settings that I could do with my chip. If you got a better chip than me, you could probably do 4 gigahertz on auto with mode 3 probably, or mode 2. And then you're set, because at that point, if you could do 3200 RAM, that means you have like a golden chip, because that means your IMC on your Ryzen chip is actually really good. So that's basically the summary of the MSI motherboard overclocking experience. But that's all you could do. Like, you want to tune P states? Too bad, you can't, because they don't have it there. So if you want to do the P state overclocking, and that's probably where Ryzen's really going to develop its real overclocking over time. I think it's not going to come from people doing AI tweaker in Asus Crosshair 6 or any of the equivalents. It's really going to come from the microcode updates and modifying of the P states. Yeah. Well, actually, MSI has a good one. MSI has a pretty good write-up on LLC if you look it up. Okay, so when I researched LLC, I first read MSI's article, and then, like, recently I found Buildzoid's video on explaining it, which is kind of like what I did here. It's the same sort of scenario where he drew, like, the same thing. He drew the load curve, he drew the voltage curve, and the peak is the main thing you want to be concerned with, for overvolting with LLC. But yeah, so with the crosshair, now we'll talk about the Asus crosshair, because that one was a completely different experience. And that was an eye-opener in terms of, like, how Ryzen has to really adopt some new strategies going forward with it, at least for the overclocking in the long term. So let me bring up the Crosshair 6 here, and then we'll talk about it. And we'll probably go back and talk about the chipset too, because there's some interesting things. I've been testing the chipset, the X370 specifically, with different kind of PCI devices. For example, the AverMedia Live Gamer HD does not work with Ryzen right now, so we'll talk about that toward the end of this stream, after we talk about memory. So let's talk about Asus Crosshair 6 Hero. Let me find a picture of it real quick. So let's just get this guy here. So then I decided, okay, so people are probably wondering, like, why did I buy the Asus motherboard to test it out? Well, I'll tell the story. People who watched the last stream, they probably know the story already, but I originally bought the Crosshair on launch day. So this is the, for those wondering what motherboard this is the Asus Crosshair 6 Hero. So this is their top of the line Ryzen or AMD AM4 motherboard. And the titanium that we're talking about earlier was MSI's equivalent. So with this motherboard, there were some issues with it. So mine was dead out of the box on launch day, so I had to take it back. And then that's how I got the MSI, because Micro Center only had 5 of these in the back. They didn't have any other motherboards. My guess is the only reason why the titanium was still in stock was because it's the most expensive motherboard, because this is a $299 motherboard. This is a $255 motherboard. So yeah, that's probably why they had 5 of these left, because after launch day, literally, like, I remember I talked to the guy in the morning when I got there to pick up my Crosshair and the 1800X, and he's like, this day's gonna be awful. He was like face palming, and he was like, oh man, we sold like over 800 pre-orders. So clearly there was demand for Ryzen, and that was just one store. And we all know that Newegg and Amazon were sold out already, like before launch day even showed up. So anyway, I was just happy they got my Crosshair. I go home, I do a live stream, I build this thing, then it doesn't post, and it's embarrassing. The RAM, it wasn't the RAM, it wasn't the CPU, it was the motherboard. So anyway, I got a bricked motherboard out of the box. So I swapped it for the MSI. Then 3 weeks later, Fry's Electronics has 2 of these Crosshairs in stock. So I'm like, you know what? Okay, here's the reason why I got the Crosshair. 1, this motherboard is currently on a GISA 1.003 with the latest beta BIOS, and the beta BIOS is 1001. BIOS version 1001. Actually, maybe it was 1002. I don't remember. Anyway, it doesn't really matter. It's a 1000 number. So they had some other issues where they had like you would turn on your computer and it would show up saying it's updating the BIOS, and then it bricks itself. And so they fixed that with 0903 or 2. I forget what the version was, but anyway, if you have a Crosshair 6, you want to be on 0902 or newer, meaning a 1000 release. You don't want to be on the, I think it was 05 something, but yeah, it was really bad. So yeah, it's okay. Yeah, well, I'll say one thing about MSI. MSI technically is actually not ahead in terms of the version and the compatibility. It's actually behind significantly if you think about it, because it's only a GISA 1001, but apparently the older microcode allowed the condition for disabling overclock, the condition for disabling all the low power states basically, if you activate what AMD internally calls overclock mode, and it disables all the low clock P states, with MSI, the only way you can trick AMD into, or you can trick Ryzen into thinking it's not in overclock mode, even though you're overclocking, is to leave voltage on auto, raise your multiplier, and use LLC for stability. So that's a bug. I'm just want to clear that up. MSI is the best, not because it's the furthest ahead in terms of functionality, but because it's actually doing okay because of an old bug with version 1001. So the conditions, why can't I spell? Conditions to disable, okay, whatever. Conditions, okay, basically, flags that enable OC mode. 1. Entering a manual vCore. 2. Changing the multiplier. 3. I think entering an offset also counts, but I'm not sure. But MSI doesn't even have offset mode. See, that shows how far behind they are. So basically, if you enter a manual vCore, if you touch the voltage, you change the voltage, AMD's like, nope, no more power saving for you. And by the way, now you're on overclock mode. And same thing with the multiplier. You change the multiplier. If multiplier changed, you're in overclock mode. See, that's the way the microcode checks that the condition is met, that you're overclocking. Now, with MSI, or rather Agisa 1001, there was a bug that basically said that this condition doesn't actually exist, or actually that this condition doesn't have to be, or this condition can be true, and it will leave power savings on. That's how I was able to overclock my Ryzen 1800X to 3.9 and 4.0, and how I was able to keep my downclock and all my low power states enabled. So if you try to do that on the ASUS board, it's not going to work, because it actually follows what AMD says for it to do. So if you key in a multiplier, like if I say 4.0, if I type in 40.00 on the ASUS board, it's going to be pegged at 4 gigahertz all the time. Like, it's not going to drop to 2.2. It's just never going to change. It's going to always sit there. And surprisingly, the voltage will actually downclock a little bit, but as soon as you key in a manual voltage, it's going to be pegged to that voltage all the time. So the crosshair actually follows the rules. Now, I want to point out one thing about the crosshair is that because ASUS is cramming out all these BIOS updates like almost on a daily basis, or at least a weekly basis, with these beta BIOSes, there's a lot of bugs. And if you were watching the stream on Saturday, you saw that we actually encountered a pretty bad bug. And I actually found the bug on one of the forums. Let me see. So I did some research on the weekend to find out what was actually wrong with my ASUS board. Because if you guys remember, when we were overclocking the crosshair, like, we would up the voltage, and then all of a sudden, like, it looked like the system was way, way, way overvolting. Like, we were seeing it, like, exceed 1.5 volts, like, a lot of times. Like, it was really scary. I was afraid that it was gonna just burn up my 1800X, my $500 CPU. So I tried clearing CMOS and all that stuff. So apparently, the bug with the ASUS, I'll type up the description so you guys can keep this in mind, because I know there's a lot of people out there that went and bought the Crosshair, because the Crosshair 6 is actually kind of the most popular, it's the best-selling X370 board right now. If you look at the Newegg reviews and the number of reviews that it has compared to the other X370 boards, at least the like expensive ones, the Crosshair's got a lot of them. So bug with 1001, 1002, and I don't know if it's fixed yet. If you set a manual vCore and change to auto, and this was confirmed by Elmore on the forums for overclocking. You can find Elmore on overclock.net and also on the ASUS. There's like another overclocking forum, I forgot, but he basically We found the bug, and he said that if you set a manual vcore and change to auto mode, the board keeps the manual vcore as reference. So I suspect that the bug also applies to offset mode, because if you guys watched my stream, you remember that I was actually using offset mode and I was applying some offsets. Because normally if you change it, like if you change from offset to auto or offset to manual, it will empty the register for that value that you set, and it'll just take its stock value, which is 1.35. So the motherboard was not doing that. That's really bad, because you can actually really mess things up if you key in way too high of a manual voltage and then you switch to auto. So the good news is that there's nothing wrong with my Asus motherboard. I still have it. I switched back to MSI, and everything was okay. I switched back to MSI, and at stock with the MSI motherboard, everything was running normal. I was seeing my idle vcore. It was never going above 1.5. It was okay. 1.35, whatever, was kind of like the load, or down. It was like V-drooping down to 1.22 or 2.7 or something. So my chip wasn't broken, and the Asus board wasn't broken either. It was just there was a bug with the BIOS. So that's why I don't really like beta BIOSes, to be honest. So it's okay. They just gotta work things out. So that's why, again, I feel like overclocking Ryzen right now in its infant stages is kind of not really worth it. The other thing too is because you lose so much functionality. So under AGESA 1002 or 1003, as soon as you key in a multiplier or you change the vcore, you enter overclock mode, you lose all your lower P states. Yeah, B350. Yeah, right now MSI's boards are pretty stable. Like, there's a reason why MSI is not being... Okay, I feel like there's two approaches as a manufacturer of motherboards. You can either A, be the one who's always trying to like, let's go guys, let's fix the bugs, let's send out the BIOS, take the BIOS, and you're always trying to like tune it and get updates out there, and in the end it'll work out, because you'll eventually, like, you'll fail, like with Asus, with their bricking their BIOS and their like they got all these RMAs now. It's just giving them a bad impression in people's mind, but eventually it'll all be worked out. Or you could take the approach that MSI has taken, where it's slow and steady wins the race, where you don't see them like throwing BIOSes every day out there on the web. Now, they do have beta BIOSes. The latest one is currently 131 or 1.31, whereas the official one is 1.1. So from like February 22nd, so that's pretty old. But I think MSI's engineers' approach is, if it ain't broke, don't fix it. Or they're working on the fixes in the background, but they don't want to throw it out there because they don't want to deal with like people bricking their motherboards and running into all these weird bugs and problems like what I saw with the Crosshair the other day. So it's two different approaches. Right now, I feel like MSI is the one that, even though they're behind, like if you got a good chip that can overclock pretty good, then yeah, the Titanium's definitely the better board right now. But if you're someone who really wants to go all out and like mess with B clock, you want to mess with like the P states features, then you got to go Crosshair until MSI gets those updates out. So, but even right now, honestly, like overclocking Ryzen's really not all that great. It's fun just to see, because it's a new platform, just to see what works and what doesn't work. But yeah, the performance increases is not all that great. It's really where, so that leads us into our next segue to talk about RAM, because if you want to overclock something, OMG, the RAMs. Overclocking RAM on Ryzen. I don't know why I typed all that stuff in caps, but anyway, overclocking RAM on Ryzen to 3200 plus is the way to go. Like, if you want to see like immediate performance increases without too much effort and without any danger of destroying your hardware, Overclocking RAM is the way to go. Like, go get some Samsung B-Die from G-Skill or Corsair or whoever else uses Samsung B-Die, or get some of that really, really high-end Hynix stuff that you can that G-Skill has. But yeah, like, you get the RAM running at 2933 and you're good to go. Like, for me, I've been running 2933 on two 8 gig sticks, single rank, from day one on the MSI motherboard, and I didn't have any problems. The one problem I do have with this motherboard, with the MSI motherboard, is that if I'm running at a speed that is considered an overclock speed, like 2933 or 3200, the MSI motherboard will beep 6 times and then it will proceed to post. Now, it'll post, but it beeps 6 times. So because it does all of that, it has a very long post time because of all of that. And that's something that, to blame, it's not really MSI's fault. Well, maybe it is, but again, they're taking the slow and steady approach. But it really goes back to this old microcode that they're using, which is causing the problems with the memory issues. So you don't really see that so much in the 1003, which is what Asus is using, and Gigabyte's also on 1003 now. So that's why you hear people saying, oh, get the K7 from Gigabyte, or get the Crosshair if you want to run high-frequency RAM. It's not because of those motherboards, it's because those guys, like, you could get the Asus Prime, the Gaming K5, and the ASRock boards also, like the Taichi, the Fatality Extreme, like all those guys, they have their microcode updated so they can actually run the higher speed RAM. MSI can do it too, but you're gonna have to deal with the annoying 6 beeps. So there's that. So yeah, definitely I recommend. I'll show you guys what I have. Let me see if I can find the picture of it. Hold on. It's called G-Skill Flare X, and I will get a picture of them. This is the one. I can get it in here. There. So this is, well, I don't know why it turned out that way. But this is the RAM stick that I'm using. This is a 3200 megahertz single rank, and that's what you really need if you want to run high-speed RAM, because what single rank means is that the RAM chips are only on one side of the RAM stick, or the RAM circuit board. Dual rank means you've got RAM sticks on both sides. So if you look, I've got some here. I've actually got another set of G-Skill Flare X I'm not actually using, because if you watch my last overclock stream, when I was running all 4 DIMMs, I couldn't run 3200 or even let alone 2933. So I took these out. They work, so I'm not going to keep them until... I'm going to keep them. Eventually I'll be running 32 on Ryzen. Once those microcodes come out in May, that should fix that problem. I also have the Corsair, the reviewer kit, the 3000 megahertz stuff from Corsair, the LPX. Which are actually, for those wondering, this is not Samsung RAM. So the reviewers were provided Hynix die RAM. I don't know which one it is, but I know it's single rank, and it's from Hynix, and Corsair sourced Hynix RAM. And that's the reason why some reviewers were lucky, and they got a relatively decent IMC that could clock up to 2933 with the Hynix RAM. Others weren't so lucky, and they got either an average or a lower than average IMC on the Ryzen chip, and they got like bad Hynix RAM. So you pair that formula together, and that's what you're gonna get. So yeah, so 3200 megahertz, single rank, 14. Is it 1414? What was the last number? 34 at 1.35 volts. So, and this is 16 gigabyte. That's 2x 8 gigabyte kit from G-Skill. You can also get the Trident Z, but the problem with the Trident Z is it's not guaranteed. So you can get the Trident Z. The Trident Z does look pretty good, I will admit, although it's a real pain to work with the Trident Z if you ever have to remove them and you have a Noctua NHD15 or a D14, or basically any huge air cooler, the Trident Z might run into some compatibility issues or some clearance issues. So the G-Skill Flare X is not low profile, but it's not like super high. It's not like Corsair's Dominator Platinum or the Trident Z's. So yeah. So definitely right now it's worth investing in high-end, high-frequency RAM with the best timings you can get. So that will be the Samsung B-Die stuff. So any of that stuff that's either on the QVL list for whatever motherboard you're wanting to run, whether it's BioStar all the way up from ASRock and Gigabyte all the way to Asus and MSI. That's a good question. Currently the only way to exceed 3200 megahertz on the RAM is with B-clock adjustments. So, okay, so that's actually another good thing that you brought up. So thanks for asking that question. So to run 3400 plus RAM, you will need the one of the following. First of all, you'll need Samsung B-Die, so that's basically like Flare X or whatever, Trident or whatever the other ones are. You will need one of the following. You will either need a Gigabyte. I don't know what is the model number on this thing. Gigabyte. Feel free to spam it in the chat if you guys know what the model number is on this guy, if you know what I'm talking about. But anyway, it's the... You'll need... Yeah, this is it. You'll need a Gigabyte GA AX37. I don't really like Gigabyte's naming convention for their motherboards. So this is from their Aorus line. So I'm going to call it Aorus K7. So you're going to need an Aorus K7 from Gigabyte. And that's if you want a Gigabyte motherboard. So we'll get a picture of that because it's a nice looking motherboard. It looks like this. Wow, that's a lot bigger than I needed it to be. But you'll need... Whoa. No. Why did that pay so big? You'll need one of these. I'll just throw it on top of Asus. Well, I don't want to throw it on top of Asus because Asus is also one that you'll need. So basically, you either need the Gaming K7 from Gigabyte or the Asus Crosshair 6, or you will need ASRock Taichi. I'm not 100% sure, but I think the Taichi board has it, and I think the ASRock Fatality Extreme has it. Basically, the $205 ASRock Taichi or the $249 Fatality. And I feel like the Taichi is really cannibalizing the Fatality Extreme sales because honestly, the Taichi is better looking than the Fatality Extreme, and I don't really like the Fatality naming. Like, I think that ASRock is still trying to find themselves with their marketing and their brand image. I feel like that's why you see them come up with all kinds of weird, different looking stuff. But definitely very good brand for the money. They give you a lot. They're the best ones if you want built-in Wi-Fi for such a good price. So yeah, any of those four motherboards, either the Gigabyte K7, and remember it's the K7, because not the K5, but the K7, the Taichi, the Fatality Extreme, and the Crosshair 6. Those four motherboards currently are the only ones that are going to get you to 3600 on the RAM because they offer B-clock adjustments. Now, why this may matter is if all you care about is running really, really high frequency RAM and you don't mind running your graphics card at PCIe Gen 2 speeds, then you got, yeah, I gotta get the Taichi on here now. Then yeah, you need one of these motherboards. Now, In the long run, though, B clock overclocking is not so great. So, to be honest, like, yeah, it's not gonna be worth it in the long run because it messes up so many things, like with the timings. Okay, apparently it won't let me copy that Tai Chi picture. I gotta find another one. But anyway, these should paste in here. Whoa. Yeah. You'll need either this one. So this is the ASRock Fatality Extreme, the red and black one, and then here's the Tai Chi. And I think this is actually a really nice looking motherboard. The Tai Chi. I like the white and black. It's got like this cool looking gear thing. I like how they did that around the CMOS battery, so you'll never forget where it is. But yeah, either of these, they've got B clock. So what's interesting, because ASRock is kind of like the underdog brand, right? It's like number 4 out of the big motherboard brands. At least I know BioStar's there, but you know, BioStar's kind of like in Asia and I guess Europe more than it is in the Americas. But yeah, ASRock, it's very hard to compete with them on price and functionality. Because if you notice, not only do both of these motherboards have the B clock adjustments for running up to like 36, 66 on the RAM, but they both have the built-in Wi-Fi, and if you look at that, they both have the heat pipe. Look at that. This one, the Fatality's got the heat pipe, and the Tai Chi, a $200 motherboard, has the heat pipe. Man, I thought only the Crosshair, the K7, and the X-Power had the heat pipe, but man, ASRock's got the heat pipe also, and even on the Tai Chi board. Yeah, in terms of value for money, look, they both got the debug LEDs. Oh, I see one difference. The Fatality's got the reset and power buttons, and the Tai Chi doesn't have them. See, it doesn't have them. So that's why it's a cheaper motherboard. But look, they both have like dual M.2 slots. Man, if you're someone who doesn't care about brand image and you just want like really good, if you want like the best for your dollar or your money, yeah, either one of these are pretty good. Yeah, 1600 is actually, yeah. You know what's funny though? This motherboard, this plastic shroud on the Fatality looks a lot like how the first Z170 motherboards from Asus looked. Remember the ones that had like the white? They were white here with the white. This looks like the old like Z170 Asus boards, just painted differently. Anyway. I know, and you know, I tried to comment on the videos from people like Hardware Unboxed. I wanted to throw it out here for them to try to do a video like what would happen if and no one would really do this in the real world, right? If your chip can run 5 gigahertz, you can run it at 5 gigahertz. But for science, what would happen if you were to downclock both the Ryzen 1700 and the Kaby Lake the 7700K? What if you ran both of them at 3 gigahertz? Then who would win? Who would be faster in gaming then? I know it's not like practical, because who would buy a CPU, a quad-core Intel i7 that would overclock to 5 gigahertz, and why would they ever run it at 3 gigahertz? But it's like, what if they actually did? Just to see what happens, you know? Like, oh, at 4 gigahertz. See, I'm saying 3 gigahertz. I'm saying like drop it down even more and see what happens. Scale that down to 800. There. Okay, I'll try a lower bit rate, hopefully, because we're not really doing anything crazy. Okay, so we're back. Uh, it should. We should be up. Like, I don't think. Let me see if am I still dropping. No, we're back. Man, but that's so cool though. What you guys are saying. That someone actually did that test. You know what? I might actually do a video on that on my YouTube channel. I might actually make a. It won't be Skylake because I don't have Skylake anymore. I sold. I sold off my Skylake CPU like last summer. I kept my old 4770 and my Z87 motherboard. So I was sitting on the Z87. Actually, yeah, because Kaby Lake didn't come out until January. I never got a Kaby Lake. But yeah, I sold Skylake because I just remember being underwhelmed. I built a second computer, Skylake, and I had the 4770 since 2013, and then Skylake was like, why did I buy this? So the reason why I sold Skylake instead of Haswell is because in my mind I couldn't tell any difference, and in the case of my Skylake chip, I couldn't get mine to go above 4.6, and my Haswell one had been running at 4.4 for years. So I sold the Skylake one because that one was worth more money. So I got rid of that and I kept the Haswell because I knew Zen was coming out at the time. I just didn't know when. I thought it was going to come out last November, December, and then AMD pushed it all the way back to like now. But yeah, so. But anyway, I could do a video. I could actually try that. I could get my 4770K. I could downclock it to 3 gigahertz. I could do the same thing with the Ryzen CPU, and then just run a couple benchmarks and see what happens. Like single thread. I could run the single thread, like Cinebench single thread, Cinebench multi-thread. But if you're saying someone already did that, that's amazing though. They did. Yeah, you know what? That's actually really good news because I didn't actually know that in my mind, I was thinking, okay, AMD's so behind that the best that they could probably do is Broadwell IPC. But the fact that people are showing that it's on par with Kaby Lake, that either says one of two things. It either says Intel has literally been rehashing the same stuff and just shrinking it down more and more every year, or AMD has, like, while they were developing Ryzen, they were paying attention to what Intel was putting out there. So while Ryzen was still back in engineering and development, they were looking, oh man, look, Skylake's out. Let's see how it performs. So they would gauge how fast Skylake was. So then they knew that they had to keep working on Zen, and they had to push it even more, and they had to improve it even more. So I suspect that's probably what happened. Or maybe it's a combination of both. Intel doesn't really have to do anything, and AMD has to do everything to catch up. So yeah, no, I remember the video. Yeah, I saw the video where the guy ran Ryzen at like 3600. And it's, yeah, for minimums, so your 1% lows, your 0.1% lows are much better on Ryzen compared to Kaby Lake. And that makes sense because you can divide up all the background tasks among all those extra cores and threads. So yeah, and I guess maybe you guys don't remember this, but back in the day, more than 10 years ago, back when AMD was actually better than Intel, like hands down better than Intel in the tech world. So we're talking AMD 64. If you guys ever remember the Athlon, like the Athlon X2, socket AM2, even before that, like socket 939, which was actually my first desktop computer I ever built. And that was for like World of Warcraft vanilla back in like 2006 or 2005. It was like way back. Yeah, like the early 2000s and the late 90s, AMD was just hands down better than Intel. And if you think about it, it was exactly what we see now. And if you guys watch Level 1 Tech, Wendell, if you ever watch Wendell did he was like spot on with his analysis of Ryzen. Like he was saying that it's almost like a return to that era where AMD is so much more efficient than Intel. Like the only way Intel can compete with AMD is to run their CPU way up there in the frequency, while AMD, it's like Intel's having to fire like on all cylinders like this, like go real fast, and then AMD's just like going like this and getting equivalent performance. So yeah, you guys remember, let me pull it up, like AMD 64 3000 plus. If you remember this CPU, this one, you guys remember this CPU? I don't know if anybody here remembers the CPU. This is the, or if you ever remember this box. Do you guys remember this? I don't know if anybody here remembers this. I remember it because that was my first computer. That logo, the AMD 64 logo. We'll just throw it on top of the Flare X. That CPU right there, AMD 64, you, like, any enthusiast back then knew that CPU was a legend. I built that computer in the year 2000, in the summer of 2006. I put together my very first computer back in the day. It used a single core, that one right there, single core, because the dual cores didn't have the orange, they had like a green. Single core, socket 939. It wasn't even AM2, it was socket 939 AMD Athlon 64. That was the logo. This was back when we're talking about like Windows XP, and Windows was trying to push Windows. There was a whole initiative. AMD came out with 64-bit CPU, breaking the 1 gigahertz barrier. So they were like breaking world records. They had an integrated. They integrated the memory controller into the CPU for the first time. They were the first ones to do that. Yeah, exactly. You know exactly what you're talking about. Exactly. And I remember because I used to work at Fry's Electronics in the computer section, and this was my summer job in 2006. I was working at Fry's. I built my first computer using AMD, and you know what? Back then, I actually felt sorry for Intel because I remember all my coworkers, they would say so many bad things about Intel. Like, in my mind, some of the stuff they said to me, like, or that I overheard them say, didn't even sound right. Like, it didn't even sound fair. Like, they were talking so much trash about Pentium 4 back in the day and making fun of it. And then when customers would come in, they would completely just persuade the customer to stay away from Pentium 4, especially on a laptop. It's awful. Get a Turion, get an AMD. If you're going desktop, get Athlon. They were like, I remember there was a guy who came in. He wanted to buy a desktop computer to play vanilla WoW. He wanted to play World of Warcraft, and he was like, I want the best gaming PC for the money, and tell me which one that's gonna be able to run the game smooth. And I walked out. I was like, I immediately knew AMD 64, because I'm not gonna lie, that's the one you want. And if you go back and if you look at, yeah, if you think about it, Pentium 4 was Intel's bulldozer. Pentium 3 was like Intel's old Phenoms. So, although over time, because Pentium 4 could clock so much higher than Pentium 3, Pentium 4 became better than Pentium 3. And that's the reason, the same thing with Bulldozer. Bulldozer could clock to like 4.7. Remember they got like the FX 9590? And that thing could beat Phenom 1100T hands down because of the clock speed. So, same deal. Like Pentium 4 equals, well, you know what, let's type it out so people can see, so people can understand. Because I think people need to be educated on this stuff. Because a lot of people don't really know that. It's like Pentium 4 equals Bulldozer. Pentium 3 equals Phenom 2. That's basically what it is. That's the equivalent. So back then, AMD was the better one. Intel was the worst one, like the underdog in terms of the technology, in terms of who had the better engineering. Then the tables flipped in the fall of 2006 with the release of Conroe, with the Core 2 Duo, and we all know the rest is history. So, AMD's back. That's all I gotta say. Like, it's interesting how, you know, the weird irony of it all is if you look at the AMD 64, back how they use the color orange on black. Notice how Ryzen is using orange on black, or kind of like orange on gray, but you get the idea. It's kind of like they're returning back to the glory days. So definitely Ryzen is far more efficient than Intel's current architecture, which is really, to be honest, Intel's architecture is just a continuous rehash of the Nehalem architecture that they came out with back in 2008. So Sandy Bridge was a big step on top of Nehalem, but ever since Sandy Bridge, they've just done like small increments in improvements in power efficiency, and they really focused on mobile. Yeah, I saw Dord TV's review. Yeah, see, he understands. So I think, like, in terms of the YouTubers that do the technology stuff on YouTube, Wendell and Jim from Adore TV and Hardware Unboxed to some extent, those guys, they understand. And then there's another guy called Tech Showdown, and then myself. I'm trying to get into the tech YouTube scene as well. And then Buildzoid and those guys, they actually understand the real behind the scenes engineering here in a way that they can clearly see which one is the better design. Man, I've been following Ryzen leaks since like 2015. Yeah. Well, Adore TV is actually really good when it comes to the AMD knowledge. He does some very in-depth analysis of AMD's product line, not just the CPU but also the Radeon line. Actually, I think he's focused more on Radeon than he has on Ryzen, but that's just because Ryzen hasn't done anything until now. But anyway, yeah, clearly, if anyone's looking for a new computer, like, Ryzen's definitely a hands down solid pick. If you want a modern platform, you want extreme value for money, because, like, back in the day, AMD actually did sell $1,000 CPUs. It used to be, it's funny because the AMD FX line, let me see if I can find it here. This thing. If anybody remembers this thing, I can actually copy the image. I don't know if it's gonna let me. Yeah, this guy. The gray, like the silver dark gray Athlon FX. This was AMD's $1,000 CPU back in the day. Because I remember we had it in stock at Fry's, and no one would buy it because it's too expensive. They would just buy like the $500 one, which is basically like today with the 1800X. And Intel didn't really have any equivalent competition except aside from the Xeons, but back then you couldn't really get Xeons for the consumer market at all. And AMD had the Opterons to compete with the Xeons, so I think AMD's Opteron series will be replaced by Naples, or updated with Naples, later this year. Yeah, Jim Keller is pretty much the legend at this point in terms of, like, CPU architects out there. So, but, alright, so I was talking about overclocking, and I feel like overclocking on Ryzen isn't really going to amount to much right now. It's almost like it's not worth it, because unless you can overclock to 4.1, either on the MSI motherboard with just mode 2 and 3, or maybe mode 1, I guess, it's not really worth it. Like with all the other ones, you lose all your power efficient. Oh, what the? Oh, I got a sub, man. Thanks for the sub, man. I put so many things on top of my overlays I didn't even notice that my alert thing wasn't even up at the top on the top layer because we put the paint and everything on top of it. Uh, you can either refer to me as, well, okay, since you guys are on YouTube, yeah, you can go by a GTR or the Acclaimed. I'm known as the Acclaimed. The Acclaimed on my Twitch channel. That's my Twitch channel, actually. So, so kind of like, you know how Adore TV is Adore TV? You can call me the Acclaimed. Or Buildzoid is Buildzoid, or actually Hardcore Overclocking is Buildzoid. So, yeah, so one thing I'll also mention is right now, like, there's so many weird issues with, there's so many microcode updates needed that, if you do B clock adjustments, you're going to have a really hard time with things that connect to your PCIe slots, especially the ones that are down here in the X370 and go through that PCIe X4 lane. So what I found right now, and I haven't even been doing any B clock adjustments, so if you guys watch my Twitch channel, you know that I used to stream with an AverMedia Live Gamer HD capture card for my PlayStation 4. That's what so basically I have the PlayStation 4 connects into the AverMedia card. The AverMedia card is a PCIe X1 slot. Let me find that here. AverMedia C985. Let me find a picture of that. So I use this thing, or I was using. I can't really use it right now, at least not with Ryzen. So I use one of these. I use this Live Gamer HD. I connect it into one of the PCIe slots on the motherboard, and what happens is when I connect it to the MSI motherboard, so I'm connecting it like right here. I connect this into this slot, or I connect it into this one. Oh, and just real quick, well, I'm probably going to do a review on the MSI board and the Crosshair motherboard, and I will point out one thing real quick. If you run all-in-one liquid coolers or custom loops, both of these motherboards are fine. They both have like the water pump header and all that stuff. If you are like me and you're using high-end air cooling, like I'm using a Noctua NHD14, which is kind of like the Noctua NHD15, it's a massive 2 skyscraper stack air cooler. With the MSI motherboard, I'm able to plug in the AverMedia card here on the top PCI X1 slot, which is really good because it goes above my graphics card. Because otherwise, the only other one that I could use is this one down here, because the graphics card is so big that it actually like almost covers up the other one. So I'd have to plug it in down there. But with the MSI board, I can plug this in. I can have that gigantic heatsink up here, the dual stack thing, and it's fine. Like I can reach in there, I can pull it out, I can even pull the graphics card out really easily. Now down here, Asus thought it would be funny or cute to put the PCIe X1 slot so much closer to the motherboard, so when I install the Noctua is like this big, and it comes down like, and the fan thing is like that. So it takes up this much space. And I can't use this slot. Like, it's completely useless. I can't do anything with it. I can't install the AverMedia on there, so it's like, that's useless slot. It might as well not even be there. If you're using an air cooler like me. If you're using a liquid cooler, it doesn't matter. And it's a real pain to get the RAM out, but that's the same with this one. So basically with Asus, I have to plug in the AverMedia card here. With the MSI one, I can plug it in here or here. So anyway, interesting things. I plug in the AverMedia into my MSI board down here, proceed to turn on the computer, and guess what? It can't post. Nothing. Like, the debug LEDs flash a bunch of random numbers. You see, like, I think it was like 64 was one of them that I remember, and then it would go to 90. It would go up to like 94, and then it would eventually stall at A2, error code A2, and it wouldn't do anything. It wouldn't pause, would do nothing. So I thought, did I do something wrong or what? So I turn it off. I take out the AverMedia card. Lo and behold, the thing can post just fine. I go and plug the AverMedia card into my Intel Z87 Haswell MSI. What is it? Z87 GD65 Gaming from MSI, and it works fine. So yeah, there's a lot of compatibility issues with PCIe cards. Now, I tried a Wi-Fi card, and it works fine. And people say they don't have any problems with sound cards. So I think right now, it's like, if I had to guess, and I already tried to open a case with MSI, and they said that they'll forward this to their engineering teams. They've already done that. So it'll be looked into. The Elgato HD60 Pro also has a problem, but it's not the same exact problem. I think it posts, but it just doesn't recognize the device as being installed anywhere. So the interesting thing is, I was trying to find this out on Reddit, and people were saying, like, Elgato actually said, try plugging it in here into the second PCIe slot, the one that you'd normally plug in a Crossfire SOI, the second graphics card. And for the Elgato, it works, but for the AverMedia, it doesn't work. So actually, I haven't really tested in that one, at least the AverMedia card, but I tested this one, and I get the same result. So I know that there's a problem with this happening. So it goes like this, it goes through here, and the CPU just, like, it doesn't know what to do with that thing. If I had to guess, it's a microcode problem. The Ryzen CPU is probably trying to think that that's a graphics card, so it's trying to out display to it or something, but it's not posting. So the nice thing about having two motherboards, because I also have the Crosshair, and so guess what I did? I plugged this in to the Crosshair to see what it would do. So I plugged it in down here, and this motherboard is funny. This motherboard, like, when you plug it in here, you turn it on, and you see, like, all kinds of weird, like, it starts flipping out and going crazy with, like, some weird numbers and stuff, and it looks like it's doing something. It thinks about it. It thinks about it some more. It thinks about it some more. It thinks about it a little bit more, and then it finally gives you the post beep, and then you get a black screen with nothing. And that's all you get. So it's like, what is that? What am I supposed to do with this? So obviously there's a problem, like, and that's with the newer BIOS from Asus. So that tells me that Agisa 103 is still bugged. It's still broken with a lot of PCIe cards. Man, 5 gigahertz Ryzen, that's gonna be LN2. That would be like a stream with LN2. We're not gonna be doing that tonight. That's an interesting idea, though. But honestly, overclocking, like I was saying earlier, right now, it's not really worth the trouble. Now, there is P-state overclocking, so I'll say the real way to overclock Ryzen. So I think, in the long run, P-state overclocking may be the real way, because I might do a stream using Ryzen Master, try software-based overclocking, because I think with Ryzen Master, I haven't really researched it too much, because I prefer to do everything in the UEFI. I think it uses P-state overclocking, which is very much like overclocking the RX 480. If anybody here has an RX 480 or an RX 470 or any of the Polaris-based Radeon cards from last summer, if you played around with Wattman, you would know that they have different power states, basically. So Ryzen Master might be the real way. Well, I don't know about the real way, but the BIOS will have to add that. Right now, if you want a P-state overclock, you have to have a motherboard with Agisa 1003. So that would be the Crosshair, the Gaming K7, the Tai Chi and those guys. That's again, it falls back on MSI to add that, because MSI is so behind in terms of the current BIOS features that with MSI you can't actually access the custom P states. And the funny thing is, overclocking using P states supposedly in the future will allow you to keep your low power P states active. So which means if you want 4 gigahertz, you got 4 gigahertz, and when you don't need 4 gigahertz, it'll actually downclock all the way back down to like 2.2, and it will still save power. But yeah, like, the funny thing is, if you want to access all that stuff's actually found under the advanced section of the UEFI interface. It isn't even under AI Tweaker or any of the traditional overclocking area in the BIOS. Has nothing with P states. It's all hidden in the advanced section, which is where you like check your USB ports and your other stuff. Well, I think part of it is the node that they're using. They're using Samsung's low power node. So Ryzen was designed. There was a lot of like key design goals in mind, like the power. It had to be very efficient on power. It had to be very efficient, which is why it can do so much at a lower clock speed, going back to the old Athlon glory days. But yeah, I feel like the current chips that are there, probably you won't be able to really get that far above 4.1. Like, honestly, I think the only chips that can overclock above 4.1 reliably would be the 1800X, and that's why they charge more money for it, because it's a better binned part. It's their best binned part. That's the reason why the XFR can turbo all the way up to 4.1. Yeah. Yeah, and that's what's going to happen. I mean, think about it like, remember how Bulldozer was and Piledriver? It was the exact same thing. Like, the 8150 was a 3.6 gigahertz, and fast forward a year later when Piledriver came out, the FX 8350 came out, and that thing could go up to 4.2 gigahertz. So it's the same thing. Like, next year, Zen Plus comes out, and you've got a Ryzen 8 core that can do 4.4 gigahertz instead of just 4.2 gigahertz. So yeah, and your overclocking headroom on that might be better. So you might be able to do 4.6 at that point, because that's how Intel was. That's how like, remember Nehalem? Like, Nehalem couldn't really go that much over 4 gigahertz. Then Sandy Bridge came out, and people were able to hit 4.5. Then Ivy Bridge couldn't really do a whole lot better. It was just the same thing. It was just worse because they stopped soldering the chips. And then Haswell got even worse because they put Fiverr. They integrated everything in the CPU, and the thing ran hot like a curling iron. And then they thought that was a bad idea, so with Skylake, they kind of like did a 180. And that's why now Kaby Lake's out, and Kaby Lake is just Skylake Plus, right? So that's why they're able to hit 5 gigahertz. So yeah, Zen Plus will be similar. I don't really think it's going to do 5 gigahertz, but it'll probably do like 4.4. You'll probably see like the flagship 2800X a year from now, and its XFR is like 4.4 or something like that. To me, that sounds realistic. Yeah, I'm thinking like 4.2, 4.3 for the all-core or half-core, and then like 4.4 for the XFR. Yeah, I never had any of the old Intels. The only old Intel I have is in a laptop. I have a Core 2. I have a Core 2 in a laptop, like an old ThinkPad T400. I got a my CPU lineup is I have the old AMD 64 Athlon 3200 plus. It's it's funny how their old marketing was like. Remember how they had those weird SKUs like 3000 plus, 3200 plus, 3500 plus single core, or Athlon X2 3400 plus or 3600 plus. So that's funny because it's like that number was supposed to be the Intel speed because the Athlon only ran at like 2 gigahertz or 2.2 gigahertz, but what they meant was it was equivalent to Intel at 3.2 or 3.4 gigahertz. So which is kind of like what you're seeing now with Ryzen being so much more efficient than the current Intel core architecture. Yeah, but part of it also is, and I remember there were some people telling me this years ago that all the developers are using Intel-based compilers for their games and applications. So even for add-ons for stuff like Microsoft Excel, they write these programs or these scripts and they compile them using Intel-based compilers. So the code path knows it's aware of how Intel's caching system works, so it knows how to thread properly that way. So then when you run it on an AMD CPU, it has to kind of like fall back to some sort of emulation, and then you get all kinds of performance penalties. So basically, it's like in order for AMD to significantly beat Intel, it would have to outperform Intel so much. Like, it can't be 100%, 100%. It has to be more like AMD has to go like 150% to really stand out and actually be way better than Intel. Yeah, I don't know. The whole thing about like Cinebench or something, like the old Cinebench 11.5. There was something about that also. Yeah, but at least for the CPU threading, that's true. Graphics though, I'm not so sure about that. Graphics, I sometimes I don't understand like why a console port to the PC. Yeah. Anyway, we're going off topic. We're about to start talking about like a different company with a green color, and yeah, we don't really want to go there right now. So RAM, yeah, RAM overclocking. I would say okay. So let's talk about the Infinity Fabric here because there's some interesting stuff. So with Ryzen, we have the memory lanes. So if you think of this, I'm not 100% sure about the PCI lanes. Actually, I think that holds true. I think the Infinity Fabric is like, think of it like a web that actually has all of this stuff. Well, okay, not that stuff. But it's basically, it has all this stuff like a web. You can think of it like it has all this stuff. So this is what they call, yes, they call it question mark, Infinity Fabric, or it's also known as the data fabric. So this interconnected web of like cache and trace, well, like different traces in the CPU, all these different little microscopic wires that then connect to your PCI Express and your RAM and your the chipset and all that other stuff, and of course the core complexes. So you have the core complexes in here. So we'll just kind of like draw on top of this Ryzen logo. So you have one here, and you have another over here, whatever, and then you have the cache in the middle, and you have the other cache. Then you have your stuff that talks to the RAM. Then you have the stuff that talks to the PCIe. So the data fabric, the speed at which the data fabric transfers data that to the RAM is directly tied to the speed of your RAM. So not the speed of your RAM, but rather the, well, yeah, it's the data rate of your RAM. Because if you remember, RAM is double data rate, so that's why if you're thinking of 3200 RAM, it's actually, so the Infinity Fabric speed would then be 1600 megahertz. So that's why if you look here, I don't know, is this on the stream? Yeah, this is on the stream. So you can see this is mine that I'm currently running. So I've got 16 gigs of Samsung BDI. This is the Flare X stuff. And it's running at 14, 14, 14, 34. Now the timings are good. Like, yes, you want good timing. You want tight timings on the RAM for the RAM performance, but really you want this DRAM frequency number here, or this. Notice how, see this NB frequency? That stands for North Bridge. So anytime you see North Bridge, that's basically Infinity Fabric. So this could literally say Infinity Fabric frequency 1463.7. So notice how those two numbers are exactly the same. This is the reason, not so much the timings. The timings are great and wonderful for the RAM, but the DRAM frequency is directly tied to the Infinity Fabric frequency. So that's why the higher you run your DRAM frequency, the higher you run the Infinity Fabric frequency. So that means that every single thing that you see in this black outlined area here on the diagram will run faster and perform better. That's why the timings only apply to these guys. So the timings, the 14, 14, 14, 34, 1T, that only applies to them. That doesn't really matter to the Infinity Fabric, because you want to improve the throughput of the Infinity Fabric to improve the CCX to CCX communication. Basically, you want to reduce the latency by running all this other stuff faster, or at least the Infinity Fabric faster. So that's the reason why right now, even though you can't really do a whole lot with the overclocking right now until micro updates smooth things out and you can run things with the lower power states enabled, it's the best thing to do is to get your RAM running as fast as you can if you really want Ryzen to shine and basically be what it's meant to be. So yeah, so hopefully this illustration here clears up or paints a better picture of why high speed RAM is so important with Ryzen. So aside from all the weird issues with the PCIe, and again, like, it's sort of like a catch-22, because if you want to run like 3400 plus on your RAM, you have to do B clock adjustments. And when you do your B clock above, if you set B clock above 107, I believe, someone was saying it was okay to go up to like 115 on the B clock, on the base clock. If you go any higher than that, that starts throwing off like all this stuff down here, like these, potentially your SATA, and that's not good because there's already all kinds of weird incompatibility problems that need to be worked out. So if you start messing with B clock, then you're gonna create other problems that it'll be harder for you to tell, like, is this a real problem, or is this a B clock overclock problem that's specific to my overclocking? So it's, you're going to introduce some additional variables there in terms of affecting your stability of the system. So that's why it's kind of like, if you can get 3200 at the timings that I've listed up here, that's pretty much golden. Yeah, 3200 and the 14, 14, 14 and the 1T, that's really good. I mean, you're pretty much, your gaming is equivalent to Kaby Lake at that point. So, and if you're multitasking, it's already like outperforming Kaby Lake. So, yeah. Wait, are they using... No, they're using the Infinity Fabric. Maybe to increase stock prices and high-end DRAM. I think there's a lot of other variables there and a bunch of other manufacturers and vendors that are at fault for the DRAM. But yeah, I get the joke there. I don't know, because okay, that question about the Infinity Fabric being independent, you can overclock it independently. That's a very interesting point, because it used to be you could actually yeah, you could set Northbridge different from DRAM. If you remember how Phenom and AMD FX line used to work. I feel like Northbridge is kind of the wrong... Well, I guess it's okay to say refer to that. When I think of Infinity Fabric, the word that comes to my mind is not Northbridge. It's the word hypertransport. Hypertransport was AMD's point-to-point interconnect they used to connect the CPU to the Northbridge, because back then, in the days of Athlon and Phenom, you had, and even AMD FX, you had a Northbridge, which was basically, you had the CPU. So I guess, you know what? Do I have enough room? I'll try to draw it out here. So you used to have the, well, you know what? Here, let's find Phenom block diagram. Here's, well, is that gonna post? Okay, let's see if we can get this one. With AM3, you used to have this setup. I'm just gonna like go on top of over here. Yeah, I'll just go over here. I'll go over here on top of MSI. So you used to have this setup. So if you look, AMD used to have the CPU. So that's the socket, AM3. So that would be like Phenom, your Phenom 1100T, or your 965 Black Edition. Then you had your Northbridge, which is the 890FX. There are some settings for the voltage, that's true. And depending on the BIOS, the settings are all random. Like, I mean, they all have different names. Like, MSI calls it, I think MSI calls it SoC, System on Chip, which is the Infinity Fabric. And some of them call it Northbridge. They call it like NB voltage, or CPU NB. So they need to update the terminology. They need to put like IF or something, Infinity Fabric, so that people know exactly what they're talking about. But anyway, yeah, they used to have the Northbridge and the Southbridge. And now what you have is Ryzen, the Infinity Fabric is basically, okay, this thing you see here, just 5.2 giga transfers per second. This was the hyper transport. So this thing is the real, if you think of the Infinity Fabric as a web, so if you remember how I drew this web here, so it's got like all these traces that connect all these different things. The Infinity Fabric is basically a whole bunch of hyper transports that connect all your memory and your storage and peripherals and the chipset and everything, and the graphics cards all to the CPU directly. And that is basically hypertransport and Northbridge combined on the CPU chip, as opposed to a separate chip that used to be on the motherboard. So that's what Infinity Fabric is. And then Southbridge is basically X370. That's basically your Southbridge. So that's where your SATA and your USB connect. If you see, back then you have SATA back here. You have really old stuff, Parallel AT. Wow, I can't believe they actually ran the Ethernet through there. I think the Ethernet on this one... That's interesting. I don't even know where... Huh. I don't even know where Ethernet is on here. Maybe it's on the... Wow. Ethernet's actually not listed. If I had to guess, it's probably going through... I don't know. I would assume that it goes directly to the CPU. That's something that I don't actually know. I don't actually know where the Ethernet connects. Maybe it's on the X370, but it's not listed on that diagram that I have. Yeah, it's probably the X370. Yeah, SoC, system on chip. Yeah. So it probably well, if it's system on chip, it probably goes straightly through the Infinity Fabric, but it's not listed in the diagram. That's weird. Anyway, I assume that it's either going to go through the Infinity Fabric or it goes through the South Bridge or the X370. So, or the B350. But anyway, you can see the similarities or the improvement. Yeah. Yeah, the chipset, right? Because yeah, it goes through the X370, and that makes sense because because vendors can choose to go with either the killer NIC or the Intel one. Yeah, because it's up to the motherboard manufacturer. So basically, what when I imagine Ryzen like at the microscopic level, I imagine like the CPUs with the core complexes like kind of like floating in this web, and there's like all these like web traces that are hooked up to them, and then they have all these traces that then run out to like PCIe lanes and memory lanes and stuff. And that whole web is the Infinity Fabric. So but yeah, you're gonna want to run if you see here, single rank. See how I've got single rank RAM with these timings? So stuff like that is gonna really help improve Infinity Fabric, because the North Bridge is tied directly, or I guess the Infinity Fabric frequency, like I said earlier, for those who just joined on Twitch, because I'm noticing I have some viewers on Twitch now that are watching. We were talking about how right now with Ryzen you're better off waiting. Like if you want to overclock, it's better. It's in your best interest to overclock RAM instead of the actual CPU. Just leave the CPU on stock, so you get the benefits of all the power saving features and the efficiency gains, and you get your XFR to turbo you up to, depending on what CPU you have, of course. If you have the 1700, then obviously you don't have that, but with the 1800 to 1700X, you're doing like you got your XFR, so. Well, like I said, the only problem with running, yeah, I personally don't recommend going above 3200 right now, because of the issues that I just outlined with the South Bridge. If you run your B clock up, and there's already all kinds of weird incompatibilities, like I mentioned with this AverMedia live gamer, it doesn't actually work with Ryzen right now. So I don't know what other different devices people have out there, but if you run your B clock up and all of a sudden your Wi-Fi PCIe card doesn't work, or you have some issue with like a really old hard drive or something not being detected, then, or you get write errors to your data and you get data corruption, that can be pretty bad. So that's why I feel like B clock adjustments aren't really all that great right now, and it'll also make it harder for you to determine if you have a problem due to B clock or if it's an actual problem that is like what I mentioned with the AverMedia card not actually working, where it has nothing to do with the B clock, it just doesn't work with Ryzen right now. So that's why I don't recommend going above 3200. Oh, yes, they do. I mean, and people have shown that already. There's like several videos out there that show that you can get up to 32. Well, see, it depends on the RAM, and that's why everybody keeps recommending the Samsung B die, because you're gonna have to overvolt your RAM, and even then, it's not really guaranteed. But what I'm saying is, the only way, yeah, and Hussein's saying the right thing, like, the only way to get above 3200 is to do B clock adjustments, and I really don't recommend B clock adjustments because of what the issues I was talking about earlier with the X370. Like, that's why even though like the K7, the ASRock stuff, and the Crosshair, they all have the B clock, honestly, it's just kind of a marketing gimmick. I guess it's useful for if you're going to do LM2 and you're trying to do like overclocking world records, then yeah. But if you have like an MSI X Power, which doesn't actually have a it doesn't have a B clock adjustment. Actually, I don't think MSI has any motherboard with a B clock generator on any of the boards. They claim they're gonna release one later, but I don't know. That'll probably be like Titanium Revision 2 or something in the fall, or maybe the summer at the earliest. But yeah, like it's if you don't have a B clock generator, if you have a gaming K5 or an MSI X Power or an MSI Carbon, it's not a big deal. You're not really missing out on much, honestly. If you can get 3200 with beta BIOS, then that's good enough. Oh, I think yes, yeah. I think it would definitely be in AMD's best interest to fine tune the Infinity Fabric via microcode updates to be able to run at a higher memory frequency, like 3600, for example. I mean, because come on, we've already got like 4000 megahertz kits out there. Yeah, they're really expensive, but they exist. So, and if they really want to show Ryzen off like in the best light, then they definitely want the high speed RAM for all the stuff that we've been talking about with Infinity Fabric here. So, but yeah, I think the last thing that I was going to talk about, oh no, I did want to mention that. I guess I'll talk about the motherboards again, a little bit about them. So, my experience with the motherboards, at least the two that I have tested, one being the X Power, the other being the Crosshair, is if you're the type of person who you want the motherboard, you want the motherboard to just work out of the box, and you don't really care about RGB, and you just want a nice looking motherboard, and you're probably gonna put it in like a Fantex Evolve or something, and with tempered glass, and you're just gonna leave it there. You don't want to do all the fancy rainbow RGB stuff because it looks kind of dumb on a daily basis. If you have the computer sitting right there in front of you and it's gonna be flashing all these different colors, it's like it gets old after a while. If you're that type of person, then the Titanium is pretty much the flagship right now. I remember putting together my system with the Titanium, and it was smooth. Like the armor that they have. Where's my mouse at? Oh, so the armor. Let me use a different color here. So they've got this whole armor, and they got like a patent pending on this. But like the RAM clicks into that like really, really smooth. I don't even know how to explain it. Like I remember on all my previous builds, I plug in the RAM, and it's like you gotta wait for the click, and then you gotta try to wait for the other click, and then it clicks in. It's fine. You have to press on it, and then it goes in. This one, it's smooth. Like you don't have to put that much force. It's like you just put the RAM, it goes. You hear the click, you hear the other click, and it's in. That was like the smoothest RAM installation ever. So even though they advertised like this armor stuff on the sides, I don't know what they did, but it's like, and they have the clips on both the top and the bottom. But it's pretty smooth, and the placement of this for a Noctua, it's relatively easy for me to reach in there with my finger and press on the tab to pull my GPU out. I can actually put a Wi-Fi card in this top slot here, and it actually works. Everything, like there's no clearance issues, there's no RAM clearance issues. It gives you the, let's see, it gives you the heat pipe between the VRMs. Now people were complaining about the type of MOSFETs that they're using for the high side and the low side VRMs underneath the actual heatsink. But because Ryzen can't really overclock that high anyway, that's really a no issue. The only time it would probably be a problem is if you're pushing like massive amounts of voltage through there, and you're probably on LN2 and you're trying to get like over 5.5 gigahertz or something. So yeah, and the nice thing about these heatsinks are they are designed for a lot of surface area coverage. Yeah, I remember that because I remember my first build to play WoW and Guild Wars 1. back in 2006, so that was like almost 11 years ago now, since it's 2017 now. It was like, I think I spent like $800, just over $800 to build that computer. And that was with an Athlon single core with a, I think the graphics card was it was actually it was an ATI Radeon X850 XT. And the motherboard was an EVGA, it was an EVGA for socket 939 with the N-Force chipset for SLI, which was hilarious because that was back when I didn't really know much about computers. So I bought an SLI capable motherboard and I paired it with an ATI Radeon graphics card. Yeah. Now, pretty much, if you wanted to build the same kind of computer that I built back in 2006, you would probably have to spend maybe about 1,400. Yeah, almost about 1,500. If you don't care about like RGB and stuff, then yeah, about 1,300 on air cooling with the SSD, because SSD is kind of like that's a must do. You can't build one without an SSD this day and age. Hmm. Yeah, but yeah, like they give you the heat pipe, they give you really good VRM cooling here, and they also give you the 4-pin extra. That actually does help a lot with LLC stability, surprisingly. Um, they give you the shield, which is kind of a gimmick, but it looks nice on the board. What I did with mine was I removed the shield, I put it down here, and then I proceeded to install my Samsung 1TB 960 EVO here. So, but you got U.2, you have dual USB 3.0, and one is right side angled here. You get 6 SATA, you get U.2, which is actually on a switch that is connected with this. And MSI, actually, they prioritize the M.2. So what that means is if you install an M.2 and you also proceed to connect the cable for the U.2, the system will boot to the M.2 and it will not boot on the U.2. So there's a priority ranking system there where M.2 is favored over U.2. And then they have another one down here which is shared on a switch with this lower PCIe X8 slot here. So that's Gen 2 X8. So, and then you have a little 6-pin for your graphics cards if you're doing like Crossfire or SLI or whatever, and you're overclocking them. So that's the X-Power. It's a really nice board. It has the debug code. Nice thing about the debug code is when you are booted into Windows, this will display the CPU temperature. What else? Yeah, that's basically the MSI motherboard. My only gripe with MSI is they don't give you enough USB ports on the back. I would have liked at least 2 more USB ports. But they do give you 2 USB 2.0 headers, which is nice, and they give you USB 3.1 Gen 2, so that's really nice. They've got the water. Well, they have RGB header here. They've got, I think, a water pump header here, and they've got another one up at the top somewhere. I think it's like up here, and the CPU fan header's there. Poor placement on the CPU fan header, though. I don't like where they put that. It's really hard for someone with a Noctua NHD14 to connect that in, or to remove that and then to reconnect it later while it's in the case. So, but overall, very solid board. I think it's a little bit overpriced, but you do get the buttons here. You do get everything. It has nice white LED glow. Oh, and another thing, one final thing. It does have white LEDs that light up when the RAM sticks are installed. So, for example, I installed mine in 2 and 4. So I get a white LED up at the top on both of them. And if I were to install 2 more, I would get all 4 LEDs lit. So it's kind of like a very techy motherboard. It's not all fancy with the RGB. It's a very nice looking motherboard in person, more so than I think in the pictures. I don't think the picture does it justice. When I look at the pictures, I think it looks like cookies and cream or Oreos or something, but in person, it's actually a very nice motherboard. So, and I think Adored TV will be doing a full review on this, and I also think Tiny Tom Logan will also do a review on this. He did have it in, so he will be doing that later. So I'm definitely looking forward to those videos. I'll probably put one out there. I don't know. I'm not really too big on the whole like YouTube video stuff, but I might do it because this was my daily driver for the month, basically. So now we'll talk about Asus because the Crosshair is probably the one that everybody cares about. So this one, I'll say again, just like MSI, it gives you the extra 4-pin. That's very good for LLC stability. It does not give you the 6-pin for the graphics cards, though. I think he did a mini review. If he released the video today, then that's the new video. But he did a mini review. He didn't do a full review. He said he was going to do a full one. Yeah, cookies and cream board. That's exactly what it looks like. It's a really nice motherboard, though. Very good. Like, it's very well thought out. Like, everything about it, the placement of everything, with the exception of the one CPU fan header here, is well thought out. So props to MSI because that's a pretty solid motherboard. You can't really go wrong with it. Yes, it's expensive, but it's probably expensive because the paint job on this thing was probably hard to pull off compared to just the typical manufacturing process of all the regular black motherboards. But yeah, it's pretty premium. It would probably look good in certain builds. Because it's a silver color in the dark with the white. Like, underneath the X370 chipset, there's white underglow here. It looks really good, like, in person. And then there's like a golden solid color here. It's like a goldish, like, subtle white, yellowish color there. So it's a really cool looking motherboard in person. It's kind of hard to describe in this picture. So for the Crosshair, very similar. It also has the heat pipe. That is a must do if you really want your VRMs to maintain stability long term, especially with like LLC and stuff. And then it's got the 4-pin. It has the water pump. It has the 2 CPU ones. So it's got all the generic stuff that you'd expect. It has your debug just like the MSI, although it does not tell you the temperature, unlike the MSI does when you're in your operating system. It has the voltage checkpoints. I don't think this one had that. Unless it's like up here, but I don't remember seeing it on there. But it has the voltage checkpoints. So if you got a multimeter, you can probe your CPU, vCore, your DRAM voltage, etc., your VID, all that stuff. And then it's got 8 SATA. So they did include 2 extra SATA ports here. MSI's only got 6 because they put the U.2, and they also put another 3.0 in addition to this one. So it's got 8 SATA 6. It has USB 3.1, just like MSI. MSI's is down here. So I feel like Asus, in terms of like future-proof, it's really odd because MSI's got the U.2. They give you 2 3.0. Asus gives you 1 3.0 down here. They give you 1 3.1 up here, and they only give you 1 2.0 right here, forcing you to have to buy one of those like NZXT. I got one here because of the Crosshair, actually. Got the internal USB expansion from NZXT. Basically, it's one of these little hubs that I have to run with that thing. So if you use a lot of like liquid cooling, like all-in-ones, and with the RGBs, you have to use like USB 2.0 internal headers. So the fact that Asus only has 1 there is kind of annoying. So I kind of dinged it on that. But it does give you the 3.1. It trades the positions of it. Puts 3.1 up here for more future-proof compatibility, and the 3.0 is down here. MSI did it the other way around. They put 3.0 up here and here. Then they put 3.1 down here. So they kind of trade blows there. Asus got the buttons here, just like MSI. They both have the same premium Realtek audio. What's hilarious about them is this is exactly the same. It's just different user software. The reason why I know it's the same is because when I switched from the MSI board to the Crosshair, I did not have to reinstall my audio drivers, and the Realtek UI thing came up, and it was just using the Asus ROG look instead of the MSI one. So it's exactly the same audio, although MSI does have the what do you call it? The mnemonic thing or whatever it's called. It's like it gives you an audio boost. So in terms of audio, if you want to plug up a really like high-end audio system, like an external speaker system, like if you want to set up like a surround, the Titanium has a much better amplifier on here compared to the Crosshair. The Crosshair one's good, and they advertise it and market it like crazy with their Supreme FX, but it is actually, from my testing, because I have both boards, this one, the default, the audio is definitely louder. It's noticeably stronger, and you don't hear as much random static compared to this one. So MSI is actually superior in terms of the audio. So their audio boost that they're talking about, that's real. Like it's a real deal. Anyway, but Asus is not bad though. It's definitely no slouch. And then one thing about Asus, they give you only one M.2. MSI gives you two of them. But I do like where Asus placed the connector down here a lot more than where MSI put theirs, like up here under the graphics card. I don't like it being under the graphics card, because if I ever have to remove it for whatever reason, like if I'm going to swap it out or something, with MSI, I'd have to pull the graphics card out to get to it. With Asus, I don't have to do that. It's down here. So that's better on Asus's part. Asus does give you two additional chokes. MSI only has 4 here. So my monitor is currently I'm only wait. Where did we go with this discussion? Oh. B350. The B350 Tomahawk, that's a pretty good motherboard. 3000. Yeah, that's pretty good. If you're getting a 4K monitor, you probably want to get a FreeSync monitor, I guess. Because I don't know how the RX 480 is definitely not meant for 4K gaming. And the RX 580 most likely also will not be good enough for 4K. That's the only thing I see that stands out. PSU. Yeah, SSD. Yeah, you gotta do SSD. You gotta do SSD because, like, all the games now have terrible load times unless you have an SSD. It's almost like all the game developers expect everyone to have SSDs now. Yeah, but even like Dota 2 loads up so much better on SSD. Yeah, the only thing that sticks out is the 4K monitor and the yeah, I kind of agree with the comment on 1440p 144, but I personally, if people are wondering what I use, I currently have, so I'm actually using a triple monitor setup, and they're all 1080p monitors, and they're all only 22-inch monitors. So the two monitors on the side are Asus VE228H monitors, I believe. So they've got built-in speakers. The one on this side that you see me looking at all the time is because this is where I have the Paint open on, so I'm reading off of this. And then the middle monitor is my FreeSync monitor. So I have an AOC 22-inch FreeSync monitor. It's a 75 hertz refresh rate, but it's a really cheap monitor. It was $110. I got it last summer when the RX 480 came out, and yeah, it's pretty solid monitor for the money. $110, FreeSync refresh range of the refresh range is only like 40 hertz to 75 hertz. But hey, it's still better than nothing. It's better than no FreeSync. So yeah, I've got triple 22-inch 1080p. And it's interesting because if I ever want to do like, if I benchmark 1440p, I use AMD's VSR. And on occasion, I have actually used VSR in the Windows desktop environment. For instance, when you saw me doing my overclock streams, like on Friday and Saturday, my middle monitor was hooked up to my streaming computer, and I had it set on VSR to 1440p. So I was doing 2560 by 1440 at 75 hertz on a 22-inch panel. And it's pretty sharp, but because it's VSR, it's a little bit blurry, but it works. It definitely looks a lot better than NVIDIA's DSR, because I have compared side by side Radeon's VSR on an RX 480 versus NVIDIA's DSR on a GTX 970. And yeah, the DSR has a Gaussian blur, so it looks really bad. You can't really use it in Windows Desktop, but VSR is actually pretty solid. But anyway, that's really off topic. Yeah, ultra wide, and you know, if you put my three 22-inch monitors together, it is kind of like I have an ultra wide, because I do have them cascaded, like they do curve around. Because I have a triple monitor stand, I'm using the XFX Tristan, or it's a spin-off of the Ergotech. I forgot what the model number was, but I'm using a triple monitor stand because I have a small desk. So my two monitors on the sides are actually overhanging well beyond the end of the desk, or at least this one is on this side. This side, the left monitor. I guess on you guys it's the right monitor. I'm confused now, but anyway. Yeah. Oh wow. Overclocked. I never had any luck with overclocking my panels, but that's because I buy really cheap ghetto monitors for like $100. But yeah, the best monitor I have is the one in the middle, which is the one I play my games on, which is a 22-inch AOC. I'll show you guys what the monitor looks like. I actually did a video. If you check my second YouTube channel, which is The Acclaimed, if you research The Acclaimed on YouTube, and you'll find my channel. So I have two channels. You guys see me on Game Tech Reviews, but my other channel is The Acclaimed, and last summer I did a review on that AOC monitor. I did an unboxing, I did a review of it. I also did like a GPU collection also, so if you guys are interested in that, because it has some random stuff on there. There's like a bunch of unboxings of like collector's edition stuff on there, but I kind of stopped using that channel. I may upload some random unboxings on there. I probably should have done an unboxing. Now I think about it, I probably should have done an unboxing on the MSI Titanium and the Asus Crosshair. I don't really know why I didn't do that. Oh, it's because I did the live stream on the build. But anyway, probably should have done the unboxing anyway. Yeah, AOC 22-inch FreeSync. I'm gonna see if I can find the model. Yeah, where is it? Oh, it's $115 at Newegg. Hold on, let me see if I can pull it up here. So this is the monitor. This is what I'm using right now. It's 1 millisecond gray to gray, 75 hertz, 20 million to 1, AMD FreeSync, VESA mountable. For me, it had to be VESA mountable because I'm not using the little ghetto plastic stand. I run this thing on a triple monitor stand, so it's like I don't actually use that. And yeah, 75 hertz, 1080p, 1 millisecond. There's no ghosting. It's a FreeSync monitor. I mean, you can't really go wrong with that price, and you know. And I don't have a whole lot of space. Since I'm running 3 displays, I want the smallest size monitor at the highest resolution, at the best response time, at the highest refresh rate. And that's the reason why I don't have a 144 hertz monitor, because I don't believe in buying a 1080p monitor that is larger than 22 inch. I will never buy a 1080p monitor that is larger than 22 inch. 1440p, I'm still waiting for FreeSync 144 hertz 24 inch 1440p. The first vendor to make one of those, I'm getting that monitor. It has to be 24 inch, it has to be 1440p, and it has to be high refresh rate and high response time. So no one has that. Now, the only monitor that is 24 inch 1440p is there is a G-Sync monitor, but I don't use G-Sync because I don't really use NVIDIA graphics cards anymore. I have an old GTX 970 in a really old Phenom computer, but why would I buy a $500 Acer Predator to pair with an old GTX 970? Right? So, yeah. But anyway, that's the motherboard. I mean, not the motherboard. That's the monitor. Yeah. Oh, and that's the other thing too, because I was like, man, they need to come up with a 24-inch 1440p. Because imagine how crisp and sharp that image would look. I mean, there's already like 4K 24-inch monitors, which I think is kind of pushing it. If I was gonna get a 4K monitor, it has to be 27-inch. I would never buy a 30-inch 4K, even though if you do the math, for somebody who does not wear glasses or corrective lens, the visual acuity should be, for 1440p, should be 24-inch, and for 4K, it should be actually around like 29, 30-inch monitor. But if I was going to buy 4K, I would get a 27-inch. 27-inch 4K, 24-inch 1440p, 22-inch 1080p. Those are my sizes, and because there are no proper monitors at those sizes with the features that I want, that's why I'm still on a 1080p monitor, like a really cheap set of monitors. So, yeah. Well, anyway, this stream kind of got way off topic. Yeah, that's basically all I had, now that I think about it. Pretty much try to get RAM as fast as you can to run if you're going Ryzen right now, or if you already have gotten Ryzen. And I guess worry about overclocking around like May, because I think AMD said that May was when they're gonna have the microcode updates. Because right now I'm pretty sure they are really trying to fix bugs, like for instance this one. Because to me, it's probably more important to fix bugs with stuff that's not working, that should be working, rather than fixing overclocking. Because yeah, as much as I'm an enthusiast and I want to be able to overclock my system, I also understand that from a reliability standpoint, it's definitely better to have things working rather than not working. And once that's all sorted out, then you can get the overclocking stuff working. So yeah, so the workaround for people who want to live stream consoles right now is what they're having to do is they're having to use external USB 3.1 or 3.0 based capture cards, like an Elgato HD60S or something, which is actually what I used for my near streams, because I figured out that this doesn't work with Ryzen, so I can't actually use my old AverMedia card that I've had since like 2012. So okay, yeah, we can do a discussion on B350 boards. I'll give my opinion on like which ones I think are the best ones based off of how they look and the specs and what's listed there. But I'm just glad that my Crosshair 6 was not broken, and that it wasn't my CPU that was broken, because all that stuff actually worked out. Yeah, B350 is good, because the only thing you're missing out with on B350 is Crossfire. No, not you're not missing out on Crossfire. Actually, you're missing out on SLI, and you're missing out on the VRMs. Yeah, well, I kind of think that the heat sinks on the VRMs on some of the B350 boards are not as good as the ones on X370. I will do Crossfire. I'll probably do Crossfire testing later. So we've got somebody on Twitch. Adorable Torm Booper. Welcome to the stream. You're a new viewer. I actually... Yeah. And the thing to remember is that Ryzen is a lot more power efficient than the old AM3 stuff. So yeah, hallelujah to that. You don't actually need such an overbuilt VRM. Like if you remember the Crosshair 4 and the Crosshair 5. Hey, we're just talking about Ryzen. Well, I mean, we kind of already covered all the stuff that I had on the agenda for this stream. So we're just kind of like talking about random things related to it, but are not exactly the topic. Like, yeah, VRM. Right now we're talking about VRMs and Crossfire SLI. So my graphics cards right now, like I have one GTX 970. Oh, we got a new follower. The name. Okay. Thanks for the follow there. Y'all pro AMD or Intel? Well, obviously we're talking about AMD here, but I don't really hate any of the companies. Like I'm not saying that I hate Intel and AMD's better, even though one of them is like a tiny little, like it's the classic David and Goliath story. But I don't really want to tell the whole story about AMD and Intel. But yeah, we're basically talking pro AMD right now. That's basically the topic tonight, is specifically Ryzen and the platform design, the state of overclocking, and what to expect for now and going forward, and RAM, the discussion on RAM and all that stuff. See, I don't really hate any of them, although in recent years I've kind of like grown cold toward Nvidia, if I had to be perfectly honest with you guys. Like, Intel's kind of there, and it's a huge juggernaut. It's not really gonna go anywhere. It's still gonna be the industry leader, regardless of how wonderful Ryzen is or isn't. It doesn't really matter in the big scheme of things. Eventually, what will happen is Intel will push back with some other platform, whether it's Skylake E or Skylake X or whatever, which we all know Skylake E isn't really going to be that much different from Broadwell E. And yeah, so it's just going to be a rehash of Broadwell E again with a different name on it. But who knows? I mean, the thing is, there's those rumors about AMD with the X399 or whatever it was, and I really hope that's true, because if you think about it, Skylake E is coming out in August, and Intel knows now that AMD's mainstream Ryzen, which actually is more geared toward directly competing with Intel's X99 stuff, is pretty much beating them on price performance ratios, like across the board. So we don't know what Intel will do with Skylake E. It'll be interesting. Honestly, I feel like Intel won't be able to price match AMD that much, because the X99 stuff is not very high volume, so they can't really cut into their margins that much. Otherwise, what they may end up doing is they may just abandon the X99 and just keep their mainstream, and they may introduce like a 6-core into the mainstream or something later on, like not with Cannon Lake, but with the newer stuff. And then they may just close off HEDT and just keep that in the server world in the data center. So I don't know, like Ryzen's disrupting the market right now, basically, and Intel's being really quiet about it because they don't really have any response to it. Well, they don't really. I mean, and we talked about that earlier, about that statement about games play better on Intel since devs optimize things better on Intel. It's true that a lot of code paths are using Intel-based compilers, but keep in mind AMD's architecture is x86, so in theory it should perform as an equivalent, and for the most part it does. If you look at the gaming performance, though, in the real world, like, regardless of what you see with the charts, 144 or 145 minimum versus 167 minimum, the human eye is not really going to notice that too much. And most people that are buying into, like, 7700K and the Ryzen 1800 or even, like, the Ryzen 1700, they aren't even, like, the guys, they're not even people who are, like, playing at the super high-end professional level. Professional gaming systems, like the ones that you see, like, broadcasted, where you have the teams facing each other in League of Legends, those guys are using systems with, like, ECC memory and all kinds of stuff for stability reasons, so that those computers don't crash while they're playing the game, and stuff like that. So, yeah. No, it's like the games are, in my opinion, gaming right now, Ryzen versus whatever Intel platform, with the exception of anything older than Sandy Bridge, are basically, well, not even really Sandy Bridge, because Sandy Bridge is starting to lag a little bit now, but like anything Haswell all the way up to Ryzen and Kaby Lake is pretty much equivalent, to be honest. Like, I've got all the platforms. I did a review on Ryzen like weeks ago. I compared it with Devil's Canyon, and yeah, there's a difference, but as soon as you start doing fancy stuff on your computer, like if you start doing X264 while you're playing your game, then Ryzen's pretty much better, like across the board. Yeah, because those systems that people play in the big, like in League of Legends esports tournaments, where they're actually like using other machines, not their own computer, they're playing on machines with ECC memory. There's a reason why those computers never crash, they never get disconnected or anything like that, right? So, yeah, native ECC support. I'm glad somebody mentioned that. I didn't even think of that. They're playing on Xeon systems with ECC memory. But, yeah. That's why, like, now Ryzen has the same stuff. So it's like all of a sudden now you could potentially use Ryzen in a high-end, like, professional gaming, like, arena. You could put a Ryzen system with ECC memory there, instead of a Xeon. So they really do have, Intel really does have valid competition now. So that's in a lot of different areas that people don't really, that the typical consumer is not even really aware of. So, yeah. Yeah, that is pretty crazy. I know. And the thing is, the minimums on Ryzen with 3200 megahertz have already been proven to be a lot better minimums than on Intel. Intel's able to push higher, but their bottom line is not as good. So that's why when you think about it, remember the old saying, you're only as good as your weakest link. So the gaming experience on Ryzen with high-speed RAM is actually more consistent than it is on an equivalently priced Intel system. Like the only other equivalent, like the only Intel systems that would be equivalent to Ryzen at 3200 megahertz would be Broadwell E, because they have the high core count, so they can keep the same smooth 1% lows and the 0.1% lows. I think Tech Showdown said it best in one of his videos when he analyzed Ryzen's place. He said that Kaby Lake will continue to exist, or mainstream Intel like the Z platform, like Z270, and Intel's B platform, which is like the equivalent to B350. Those will stick around. Those aren't going anywhere. They're not going to get any price drops. I remember reading so many posts on Reddit, people saying, "Ooh, come on, AMD, lower Intel's prices so we can go and buy Kaby Lake." It's like, sorry guys, that's not going to happen. Intel doesn't care about Ryzen in that sense, and it doesn't care about the people. It's not going to like, oh, I'm going to drop my 7700K to like $249 now because Ryzen 1700 is doing double cores. No. I hate to break it to you, the 7700K is still going to be $349 for the rest of the year. Depending on where you go, you might catch it on sale for like $20 off on Newegg, or you might be able to get it at a Micro Center for $299. But no, 7700K is a $349 processor, and it's going to stay a $349 processor. That depends on the platform, but like I was just saying, the analysis was Intel's mainstream line, so the Z platform, is not going to go anywhere. Is going to stick around. Now the X99, so the HEDT, the high-end desktop platform, Broadwell E, 6900K, and all those guys, 6800K, 6850K, even the 6950X, which was kind of a joke to begin with, $1,700 processor, is just completely gone. Like, there's no, at this point, if you're somebody who you're going to do production work, and I think even Gamers Nexus also talked about this, even though a lot of people gave Gamers Nexus a lot of hate, he was on the right mind track, thinking that the Z platform is good for what it is. Ryzen fits in right there between that and Broadwell E, but Broadwell E is pretty much blown out of the water. Like, there's no reason to buy Broadwell E anymore, and that's definitely good. Like, that's definitely true. Like, why would anybody go and buy a $400 motherboard with a $1,050 processor when they can buy give them the benefit of the doubt, so buy a $500 processor with a $300 motherboard, right? I mean, I'm trying to like throw Intel a bone here. I'm giving them the most expensive AMD motherboard, which is $300. It's the one you see on the screen, the MSI X-Power Titanium. $300 motherboard plus $500 CPU, the highest end Ryzen chip you can get, versus the equivalent 8-core, which would be the 6900K, so that's like $1,100 or whatever you want to say, $1,000. If you find it on sale, it's $1,000, so $999, plus an equivalent Intel board that has the same stuff. So you'd have to pay like another $300 or more for the motherboard to have the equivalent stuff. Like if you want U.2, M.2, the other M.2, all that stuff. If you want the overclocking, like if you want the heat pipe, you want this other 4-pin and all that stuff. On the Intel, you're going to be paying a hefty premium for all of that. But you do get the extra RAM slots, though. That's like the only thing you get. Like I said, what they'll do, they're not going to do anything until August. They're not going to drop the prices. They're not going to change anything. They're kind of just pretending that Ryzen's not there, and they know it's there, but they're not saying anything about it. They're not like bringing it up in conversations, because you guys got to remember, like, a lot of the sales teams from Intel are not talking to regular people like you and me. They're not talking to the end consumers. They're talking to businesses, like they're talking to corporations, like telecommunications companies, service providers who want to buy servers with Xeons and data centers like Amazon with Amazon Web Services. Twitch, for instance, needs more server capacity. When they discuss with these companies, Intel will say, we've got a Xeon. It's great. It's got these specs. They're just going to talk about themselves. They're not bringing up AMD. They're not talking about Naples. They're not talking about Ryzen. They're just kind of like, they're just being quiet and hoping that nobody in those companies know anything about it. Because they know that in a couple of months, when Naples shows up, there's going to be a problem for their sales teams. Yeah, exactly. They're not going to do anything. They're just going to... That's the smart strategy. Don't do anything. Pretend that they don't have a competitor. We are Intel. We work best with Windows. We have decent Linux support. We're the big CPU manufacturer of the world, and we are a wonderful company. So buy from us. That's what they're gonna do. They're never gonna bring up AMD's name. They're never gonna even mention that. Like, the worst thing that could happen to their salespeople is like somebody raises their hand and they're like, can you tell me how much my utility bill for my data center in wherever will be over the course of 3 years using your Xeon versus the Naples, which has so-and-so whatever, right? Like, that would be a pretty tough spot for a salesperson to be in if somebody starts bringing up questions like that. If they've got, like, a senior salesperson or something there, then maybe they have a little bit of a crutch there, but still, like, it's a pretty bad situation to be in a sales negotiation when someone starts bringing up Naples. Yeah, but anyway, yeah, Broadwell E is kind of like, no, people who have it, it's like, whatever, they've got it, but, yeah, and didn't Haswell, no, yeah, didn't Haswell E have ECC? I thought they did have ECC. Oh, wait, you're right. Broadwell E's don't have ECC. You gotta buy Xeons to get ECC. That's right. AMD's Z270 equivalent. AMD's Z270 equivalent is X370. If you look at, if you do a side-by-side comparison of the Asus... Oh, okay, I'll show you what it looks like. Okay. See this motherboard here? This is the Asus Crosshair 6 Hero. So this, I'm going to show you, let me find a picture of the Asus Maximus 9 Hero. Let me find that picture. I want to show you that picture. Okay. This is an Asus Maximus 9 Hero. If you look at the two of them, the only major difference is the socket. This one's got an AMD PGA, so it's a pin grid array socket. This one's got an Intel LGA 1151 socket. So that's the primary difference. This one costs more than this one. It has less thermal cooling for the VRMs. You can see there's like holes there, but I guess that does actually add a little bit of surface area in there, but I think you still have less thermal mass. And yeah, so that's basically the equivalent. So this one is Z270. I'll make it bigger here. That's Z270. This one, well, actually, you know what? I messed up because I don't want that circle there. Anyway, you get what I'm saying, right? Like, this one, make it 30, 26, or you know what? Make a huge font. 48 font. This is Z270. And this is X370. That is AMD's equivalent to Intel's, like, 7700K flagship. Now, the weird thing here is Intel, because for the last like 6 years or whatever, or actually more than 6 years, maybe like nine, almost, well, like 7 years. Intel has sort of dictated how the CPU market is. So you have your Z270, and that's considered mainstream. And then you have your X99, which is Intel's HEDT, which is the high-end desktop. I guess that's desktop. I'm not sure. High-end desktop. Whatever, you get what I mean. This is like the high end from Intel. So the equivalent there would be the Rampage. Is there a Rampage 6 now? A Rampage 5 Extreme? I don't even know what the Broadwell E one is. All I know is that there's a Rampage one from Skylake, not Skylake, from Haswell E that came out like in 2014. So this right here, this motherboard that you see here is a $500 motherboard. This is I'm going to repeat, this is a $500 motherboard for the Intel 5960X, which is a $1,000 CPU. That is an 8-core CPU, and that's a $500 motherboard. Now, granted, you don't have to buy a $500 motherboard, but because they're so expensive, you can kind of see, like, you can get an idea of how much money is required to go high-end with Intel, or true high-end. Now, with AMD, they just came in with Zen. They don't even care. Like, Ryzen came out, they just break all the rules. It's like some foreign competitor, like, just all of a sudden shows up. It's kind of like the U.S. car market. It's like this stuff is like the old gas-guzzling Cadillacs from, like, back in the 1960s and stuff, and then this is like the, I guess, like the Ford and Chevy, whatever. Then all of a sudden you have, like, random Toyota and Honda, like, comes out of nowhere. It's like, oh, nope, I'm just gonna undersell you by a lot. Like, this is like back in like 1980 or whatever. So it's like AMD's is coming in, completely just disrupting the market. It's like, nope, my highest price is $500. And my highest price motherboard is $300. So, yeah, that's basically what you've got with Ryzen. So, yeah, same cache, same amount of cache, similar clock speed to the HEDT, because see, people keep on comparing Ryzen to Kaby Lake, which I find really funny. But in a way, it's relevant because the motherboards are in the same sort of, in terms of feature set, the motherboards are similar. In fact, they're almost carbon copies of each other. So, yeah. You've got ECC support, you've got lower price, you've got amazing value for money with the X370 and even the B350. Like, yeah, I don't really know what else to tell you. So, yeah. That's funny. And you know what? We're giving them the benefit of the doubt, right? We're taking AMD's most expensive, we're taking AMD's most expensive part and throwing it up against Intel's like lower price Xeon that actually has ECC support. Yeah. So it's like it completely is breaking the rules. It's like, that's why Intel, it's funny, it's like Intel's like, wait, what are they doing? They can't do that. They can't put an ECC CPU on the market for $500. Like, that's not compute. That's not how it works. It's like, no, I think I'm just gonna do it. Just put it out there. It's like, you want ECC? You got it. You want 8 cores? Okay, we got that too. You want M.2 and U.2 and all that stuff? Okay, we got motherboards that have all that stuff. So it's like, you want Crossfire? You want SLI? Okay, we got X370. So, yeah. Yeah, well, guys, I guess that's pretty much like we went way over on terms of what we're talking about. I don't know how we got way into the whole Intel versus AMD discussion because I kind of try to stay away from that topic since I mean I do believe that AMD does need a little bit more marketing. Like they do need to put their name out there more. But it's just really hard to educate people over time. It's a very slow process because Intel's name is so well known, right? It's almost like saying, it's almost like why would anybody buy? Well, why would you ever buy something if you've never heard of it before? If you've been buying from like one brand from the last like 10 plus years, right? And I'm thinking from a company standpoint, like if you're investing in servers or computers or something like from an IT sales point of view, like if you're leasing, if you're buying servers or if you're buying anything, like if you're a system integrator, right? Like why would you buy AMD? AMD has to really prove themselves, and that's why they have to do stuff like put ECC support on like CPUs and sell them for so cheap. So we'll see how it goes. I think that obviously Ryzen right now is selling a lot, and that's why you can't find X370 boards anywhere right now. It's like super hard to find one of those things. Yeah. Well, they have, and they still do. If you think about Apple, I feel actually tends to favor AMD over Intel, probably because AMD will probably agree to a cheaper contract deal with them than Intel will. But yeah, like, I mean, if I were Apple, I would be thinking about, well, I would be pressing AMD for questions on mobile because I really, since remember, Ryzen was developed using Samsung's 14 nanometer FinFET LPP process, so it should be very power efficient, and it already has shown that it's power efficient. So I feel like if I were somebody at the C-level management within Apple, so that would be like chief technology officer or one of those guys with Tim Cook, I would be really interested in checking in with AMD and seeing like where they're at with their mobile stuff and even with the server stuff, even with Naples, because Apple is really big in data center. A lot of people don't really know that, but that's where Apple gets a lot of its revenue, in addition to overpricing all of their like consumer products. But yeah, like if I were Apple, I would definitely be looking to get AMD on board for like the next 3 years or whatever, because they already do in the graphics world. If you don't know, Apple actually uses only Radeon. I don't really think in the last couple of years, I don't think they really use NVIDIA. They had a falling out with NVIDIA a few years ago, so they don't really do much business with NVIDIA anymore. I don't really know. You guys can correct me if I'm wrong, but I know like the Mac Pro, the big giant like cylinder trash can looking thing, that thing's got dual Radeon cards in it. So they're pretty friendly to AMD in the reality, and rightfully so, because Apple is also kind of a small company compared to Intel. So if I were Apple, I would definitely look into partnering up with AMD, because I feel like Apple doesn't like giving Intel a lot of money, and they know that AMD needs their business, and they know AMD is the little guy. So, and Apple's also a little guy if you compare them to Microsoft. So yeah, I think the little guys should team up a little bit more. With Apple's marketing, I think Apple could really put AMD's name out there, if you think about it. That could be a really good win-win strategy for AMD and Apple, because Apple won't have to be paying Intel's prices anymore, and AMD will get the publicity that it needs through Apple's product lines, like their laptops and their desktops. And also the servers, because if Amazon finds out that Apple's using Naples in their data center, and Apple's cut their electricity cost by like 13%, then Amazon will also start like jumping on board, and they'll start going with with AMD for some of their new data centers globally. So it could lead into a pretty lucrative business for AMD. So I'm pretty sure that they already know this, because they have done business with these companies before. But yeah, Naples is pretty much the future for AMD in the long term in terms of like real revenue dollars. Like you and I were just enthusiasts. We're talking about like Ryzen on the consumer side, but in the real world, the way the company will really survive is through these big corporate contracts and negotiations and stuff. Yeah, I really think that Apple should try to go with Ryzen over Intel. I mean, they probably are looking at it and they're probably noticing how much more efficient it is in terms of the throughput, the IPC and stuff. They're running lower clocks, they're getting equivalent performance. I mean, the only way Intel is able to beat them is to run the clocks really, really high, and then when they do that, their efficiency goes through the roof at that point. So, yeah, it's kind of a return to the old AMD 64 days. So we'll see. Like, I think there'll be a couple of videos. I feel like Wendell from Level 1 Techs is probably one of the best. Who he put it really good in one of his recent videos. So if you guys didn't see that video, you might want to watch that video because he does mention some of the things that I was talking about earlier about how it was like 10 years ago, or actually now it's probably going to be 11 years ago. But yeah, well, it flipped and then it flipped back because it used to be AMD had low clocks and Intel had high clocks. AMD had low power consumption, Intel had high power consumption. Then it flipped with Nehalem and Bulldozer, and now it's flipped again. So now it's like everything's come full circle now. So yeah, I'm actually really excited to see what Raven Ridge does, and that's actually why I decided to keep the Crosshair motherboard. I know it sounds really weird. Why I'm mentioning Raven Ridge with the Crosshair when Crosshair doesn't have anything, but the reality is I have the MSI Titanium, and this motherboard actually has DisplayPort and I believe HDMI on the back of it. And yeah, I think it's HDMI and DisplayPort, or maybe it's DisplayPort and mini DisplayPort. But anyway, this motherboard supports Raven Ridge, so I'll be able to test Raven Ridge later this year with my MSI board. So I'm going to stick with the Crosshair on my 1800X because it's further along with the Agisa microcode, which is what I'm using right now. If you guys didn't know, if you want to check my CPU-Z, here's my CPU-Z. So see, I've got the Crosshair 6, and I did upgrade it to the latest BIOS again because it turned out that there's a bug with the V-core overclocking. But you see, it's normal. There's no weird issues with the voltage anymore. So I'm gonna stick with the Crosshair with the 1800X, and when Raven Ridge comes out, I will bring out my MSI motherboard again, update the BIOS. By then, it'll probably be like way updated. Or you know what? I'm thinking of actually getting a. In the interim, I might get the quad core Ryzen 5 and pit that up against an Ivy Bridge i5 3570K, the same exact CPU that I did the FX A350. If you look in my YouTube channel, you'll see the popular videos that have the high view counts are my AMD versus Intel videos, where I do like a rendering comparison and stuff like that. So I used to do a couple of videos back in the day where I did the FX A350 versus the i5 3570K because those were rightful competitors. So I may pick up the quad-core R5 was it the 1400X? I forgot what they were, but anyway, I'll be doing the quad-core Ryzen, not the 6-core, but the quad-core, the cheaper one, the 189. I may get that. I'm not committing to that 100% because I'm actually more interested in Raven Ridge to see how the integrated graphics work with the Vega stuff, but yeah. Yeah, the 1500. Wait. So that's 1600 and 1600X are the 6 cores, and what's the quad core? I thought there was gonna be 14. You know what? The naming is so stupid. They should just be 1400 and 1400X and 1600 and 1600X. That will be so easy to remember that one is quad, that two of them are quad core and the other two are 6 core. I don't know why they did 1500X. That's just. But anyway, I'll probably pick up the 1400 or the 1500X, and I may stick that with the MSI Titanium until Raven Ridge comes out. And then that computer will probably replace my, well, it'll replace my i5 system that I have, my Ivy Bridge system from way back. Oh, well then that's, I'll probably get that one then, because I can put that one up against this guy. Let me show you guys. I'll put it up against one of these. I'll put it up against, well, I don't really have all the motherboards anymore, but I'll put it up against this guy. So this is the, you can tell it's either Sandy or Ivy because of the box art. So this is the 3570K, one of the most commonly used, aside from the 2500K, the Sandy Bridge one. This one was my first Intel CPU that I used to upgrade away from AMD back in the day. Then I got the FX8350 when it came out and went back to AMD. So this is the FX8350. So I pit these two up against each other in a couple of videos on my channel. So then we have, well, I guess I can show you guys here. So like I said earlier, 15 or i5 3570K, you can see it there. And then I got the 8350. Then I upgraded again to Haswell, the i7 4770K. I've had this thing overclocked to 4.4 gigahertz ever since I got it, so it's roughly the same as Devil's Canyon stock. Or actually, it's a little bit better than Devil's Canyon stock, because Devil's Canyon stock is 4.4 on only like 2 cores. Then I basically sat on Haswell until, I'll show you guys if I can reach over here and get it, the 1800X. So I went from this, well, okay, no, that's not true. I went from this is a X965. So I went from this to, where is it? This to back to AMD again, then to Haswell, and I pretty much sat on Haswell since 2013. So I finally settled down with a processor for a while. So this one, and then now we're back to AMD again. So see, I don't hate Intel, but you know, it's AMD's better. I like them more. I think you definitely get better value for money. So yeah. So I went 6-core AMD, no, quad-core AMD to quad-core Intel to 8-core AMD, whatever. It's a 4-module thing, but whatever. Then 4-core Intel with hyper-threading, and now 8-core AMD with SMT. So that's like, that shows natural progression, right, in terms of upgrading. Yeah, because what does a, let's see, what is it called? i5 7600. Okay, let's see. Let's take a look at this. This is an i5 7600 locked multiplier. It is a 3.5 gigahertz processor, is 65 watts, and it has a max turbo frequency of 4.1. That sounds a lot like AMD's XFR. So this is gonna be the one that everybody's gonna compare it to, or actually not this one. They're gonna add the K on the end. But you know, yeah, six megs of L3 cache, 3.5, four cores with no hyperthreading, 65 watts. Same old stuff. Might as well save money and buy Haswell, Devil's Canyon, or, well, at this point, I'd probably buy Skylake instead of Kaby Lake. Well, I don't know, whatever. If you're gonna go Intel, probably best to get Kaby Lake for Windows 10, or actually no, for Windows 7. But that's kind of irrelevant at this point. I know, right? It came in a tin. And it actually had a pretty good, it had a pretty decent stock cooler too. At least the 8350 did. The other ones didn't. They had the cheaper ones, like the 6-core and the 4-core ones were kind of like, they had really ghetto cooler in them. But this one actually came with a pretty decent one. Like, I actually still have it in here. I haven't opened this thing in years. Let me see, let's get that out. Let's take a look at this stock cooler. And we're probably going to close the stream out after this, I think. See, this is the stock cooler. It still has its thermal paste. I never used it. But yeah, the tin is pretty nice. You can actually use that. See, it's got the whole, like, AMD thing going on here. It opens up like this. Yeah, this is actually pretty good. Look, like this is like, let me show you guys. This is like a prototype to the, you see that it's got like the cool like spiral fan on it. This is like the prototype to the Wraith cooler, because this one wasn't actually that noisy compared to the other ones. You can see it's got like a thick copper base plate there, and it's got copper heat pipes too. But yeah, this was the A350 stock cooler that came in that tin. So, and yeah, the A350 was actually not all that bad. You could easily get 4.6 on it. It pretty much hit a voltage wall around 4.7 or 4.8, depending on the chip. And I remember Nicholas X12 Technology. He did a review on it. He overclocked it to 4.8. At 4.8, it was equivalent in multi-thread to the stock 4770K. But then, of course, then the argument is overclock the 4770K, and then it's still winning. So, but anyway. Yeah, 8350 wasn't terrible. Like, the people who say that it's terrible, they're completely blowing it way out of proportion. I mean, in today's gaming benchmarks, yeah, it shows its age, but then again, so does the Sandy Bridge. So, I think it's scaled decently. Some people are hyping it up a little bit too much in terms of its scaling. I mean, let's be real. It's still not so good in single thread performance, but it was a decent processor. It just, some single threaded games perform pretty terrible in it. I'll give you one example. Guild Wars 2 was pretty awful with this processor. It was also terrible with the Phantoms. That's actually the main reason why I switched to Intel, was actually because of MMO games. MMO games back in 2012 were so single threaded that the Pile Driver series and the Bulldozers before them really struggled in that arena, and that's how Intel lost a lot of market share in the gaming market. I mean, AMD lost a lot of market share in the gaming gaming market. Well, honestly, DX11, if you think DX11 was brutal for Vishera, DX9 was just flat out awful for Vishera. Guild Wars 2 is a DX9 game, and I remember playing the beta on that in World vs. World on the Phantom on this thing, my Phenom 965. It was terrible. I got one of these. It was like night and day difference. I went from like average 45 FPS with this to average 75 FPS with this. Then I got this later in the year when it came out. I think like Black Friday 2012 I got this. And I was surprised. I was like, yes, this was better than the Phenom because it could boost up to 4.1 and 4.2. Then I overclocked it to 4.7 with the Crosshair 5 Formula Z, and it was doing really decent, but it was still not as good as the Core i5 in DX9. It did, but it was very, very slight though. Oh, yeah, okay, yeah, you're talking about Bulldozer, you're talking about like 8150. But against Piledriver though, Piledriver single core is actually better than Phenom. I know, because I tested both of them back in the day. Because remember, I never actually had Bulldozer. I have Vishera Piledriver, the revision, the 8350, the one that like everybody got, that actually got an AMD processor back then. But yeah, Piledriver was better than Phenom. Phenom was better than Bulldozer. But Piledriver was still way behind Ivy Bridge when it came out. So yeah, so as they say, the rest is history. So anyway, guys, Ryzen's here to stay. It's really good. So if you're in the market for building a new computer, if you can't afford the R7s, the R5s are right around the corner. I'll be covering those here in the next couple of weeks. And I guess, I don't know what I'm going to do on the next stream. The next stream on my channel will probably be on Friday evening, maybe, or yeah, I think Friday evening. We'll see. And then hopefully, but I don't know if I'm going to be doing another overclocking stream because, like I said in this video, overclocking right now on Ryzen, aside from overclocking RAM, there's really not a whole lot of benefit to overclocking. You lose a lot of your efficiency gain, and you're not able to clock it that high right now above like 4 gigahertz. So at least with the 1800X. So yeah, and all the review, I remember reading the reviews, and everybody was saying Piledriver should have been Bulldozer, or Bulldozer should have been Piledriver. Yeah, it's the other way around. Bulldozer should have been Piledriver, so that the Piledriver would have been better than Piledriver. But yeah. So if you think about it, like, there's always the first gen, then there's the revision, and the revision's always roughly 15% better on average than the initial one. So I suspect Zen Plus will be 15% better than Zen. So think of the 1800X as the FX 8150 from like 2011. So the one next year is basically going to be like the FX 8350. So the next one should be able to clock better for the same power consumption. So that should, so if you're not in the market for upgrading, I mean, next year Zen Plus, that's probably going to be a pretty solid upgrade. But if you are in the market for a new CPU right now, nothing wrong with going Ryzen. It's a solid platform. It's a very good value for money processor with the X370 or the B350. As long as you get high frequency DDR4, and I think in a couple of months the DDR4 situation will improve, and hopefully the overclocking situation will also improve a little bit. At least being able to keep the lower P states while running a higher multiplier. Right, so if you ever want to go Zen Plus, you can just drop it in next year, and that's what I plan on doing. So you're getting like all the equivalent stuff from it that you would get on Intel. You're getting NVMe, you're getting USB 3.1, you're getting USB 3.0 native support, you're getting PCIe 3.0, and you can do Crossfire, and if you got X370, you can do SLI. So if you're a green team person, then you got SLI and DDR4 and ECC. So, and the list goes on and on. So, anyway, guys, that's basically going to be it for me tonight on this stream. I'm going to take off, and I'll see you guys in the next one. Thanks.